Stop saying it works on my machine and start shipping professional-grade software to the cloud. In this course, Gavin Lawn will take a full-stack React, Go, and MongoDB application from local development to a fully containerized production environment. You'll master Docker orchestration, learn to manage environments with Docker-Compose, and deploy live to Hostinger using both manual and automated methods. By the end, you'll have a professional CI/CD pipeline powered by GitHub Actions that automatically builds and deploys your updates with every push. And thanks to Hostinger for providing a grant to make this course possible.
Hi and welcome everyone. I'm Gavin Lawn. I'm excited to bring you this video where we'll look at the technical details involved in the automation of the deployment of a full stack web application. The application that we are going to deploy to Hostinger is this movie streaming full stack web application where the client component is written in React and the server-side component, web API component, is written using Go. This application is already written and available to download from GitHub, so you don't have to worry about all the technical detail and the coding of the application, the coding details of the application. We are firstly going to use Hostinger's Docker Manager facility to deploy the application to Hostinger, which will highlight how Docker Manager abstracts away a tremendous amount of the deployment automation process and provides us with an incredibly easy way to automate the deployment process. I'll then show you how you can create a CI/CD, continuous integration, continuous deployment pipeline, so that when you make code changes on your local machine in your development environment, you can very easily, almost like magic, port those changes to the production environment on Hostinger. This is incredibly efficient and provides your application's users with seamless updates. Once I've shown you how deployment automation is made easy through Hostinger's Docker Manager facility, we'll take a peek under the hood, as it were, so that we can gain a deeper understanding of the underlying deployment concepts like Docker images, Docker containers, Dockerfiles, docker-compose.yaml files, and even a GitHub action. By doing this, we'll gain a sense of the complexities that Hostinger's Docker Manager abstracts away in order to make our lives much easier when it comes to deployment and deployment automation. So, after we've experienced the luxury of using Hostinger's Docker Manager to automate the deployment of our full-stack web application, we are then going to get neck deep in Dockerfiles, docker-compose.yaml files, and GitHub Actions, and all that great deployment-related stuff. If you're anything like me, as a developer you love designing and creating applications, but hate the fiddliness and aggravation of deploying your code to production, to the production environment on a production server somewhere.
It worked on my machine.
I hear you say, when your full stack web application fails miserably in production and you scream in agonizing pain while you try to explain what happened. But nobody cares. Nobody wants to hear your excuses.
Bring me the head of the developer,
is your manager's attitude. Your managers and your users just want it to work. Okay, so it's not quite that bad, but one way we can ensure what works in development will work the same way in production is by containerizing the components of our applications. So let's say our application is comprised of a client React component and a web API component written in Go, and want to ensure that the environments in which our components run are consistent across both the development environment and the production environment. We can ensure this consistency across environments by Dockerizing a consistent environment for the client-side React component and Dockerizing a consistent environment for the server-side Web API component. So you no longer deploy the React component and the Web API component to the production server, i.e. to run on bare metal. Instead, you deploy the containers that encapsulate each component to the production server. This ensures that the containers running, for example, on your local machine in your development environment will work the same way as they did on your local machine when they are deployed to the production server. Speaking of an application that has both a React client component and a Web API component written in Go, I recently created this movie streaming application and documented all the steps involved in building the application in this video that has fairly recently been published to the FreeCodeCamp English YouTube channel. The link to this video has been provided below in the description. One of the beautiful things about DevOps and infrastructure as code is the inherent separations of the coding details of the application from the deployment infrastructural code details. So there is a clear separation of concerns. So you don't need to watch this older video where I take you through writing the code step by step to understand all of the coding details in order to follow along with this video, which is dedicated to the containerization and deployment of the Magic Stream application, the full stack web application we are going to deploy to Hostinger in this video. However, let me just briefly give you an overview of the application before we learn how to deploy the Magic Stream application to Hostinger using Hostinger's Docker Manager facility. So it's a movie streaming service with a built-in AI-powered recommendation service. So members of the Magic Stream application can, as well as stream the movies, log in, and the app will recommend 5 movies that fit the profile of the user. And the movies are ordered by an AI-powered ranking system from the top-ranked movie to the bottom-ranked movie. So you can watch this video for all the details, but as I said, you don't need to watch this video, which shows a step-by-step guide on how to build the app, in order to follow along with this video, which focuses on the DevOps deployment side and the efficiency of Hostinger's Docker Manager facility. So there is a clear separation of concerns between DevOps and development. This means you can have one team focusing on development and another entirely separate team or individual focusing on the automation and management of deployment. The developers don't need to know the details of the deployment automation code, the infrastructure as code, and the DevOps team or individual does not need to know the details of the code that makes up the application. However, as developers, I'm going to suggest that it's going to make you way more marketable as a developer to have at least a basic DevOps knowledge. It is important to understand Docker, how to build and containerize your components, and how to use Docker Compose to pull your Docker images and run them as containers on your development environment, as well as configure your containers appropriately with relevant environment variables. We're going to look at this in this video. This allows you to, for example, easily share consistent containerized development environments with other team members, where environmental factors are eliminated when debugging code. So this allows team members to save time troubleshooting environmental factors and focus on the debugging of code logic. So containerizing your components ensures a consistent environment for developer team members and also a consistent environment across teams. For example, the testing team. So the developer team and the testing team have consistent environments from which to work. And as discussed, it also effectively and efficiently ensures the application's environment is consistent across staging and production servers. So let's start by looking at how efficient and easy deployment automation is made through the use of the Docker Manager facility provided by Hostinger. Okay, so the way I've structured this video is kind of back to front. By that I mean I'm not going to include a lengthy build-up with loads of technical explanations before deploying the Magic Stream application to Hostinger. I'm going to, right out of the gates, deploy the Magic Stream application to Hostinger running on my VPS, virtual private server, through Hostinger's Docker Manager facility. And you'll be amazed at how easy it is to deploy a fairly complex full-stack web application using Hostinger's Docker Manager facility. So, once we have deployed the Magic Stream full-stack web application to Hostinger using Docker Manager, I'll then provide a more detailed explanation of the various components involved in the deployment automation process. For example, Dockerfiles, Docker images, Docker containers, Docker Compose, and even GitHub Actions. Note that the Docker Manager facility is provided with all of Hostinger's Docker VPS plans. Okay, so let me show you how easy it is to deploy a fairly complex full-stack web application to Hostinger. I've created a new version of the Magic Stream code in a new repo on GitHub called Magic Stream Mastery. So if we look at GitHub here, you can see Magic Stream Mastery, which can be found at this URL here. And if we go back, you can see the original code, Magic Stream, the repo is named Magic Stream, is created at this URL here. And that, of course, goes with the video that I recently developed for freeCodeCamp. And it's this video here. The link is in the description. I encourage you to go through this video. It shows you the steps that I went through to build the full stack web application using React on the client and Go on the server. And then the database facility is MongoDB. And then we use Atlas to host the MongoDB database. So I do encourage you to go through this course, but you actually don't have to follow along with this video. The reasons I've created the new repo, the Magic Stream Mastery repo, the original Magic Stream repo was more about the code. This is more about deployment. So I've cloned all the code from the original Magic Stream repo, but I've included these Docker-compose files here. And the one that is important to us here is just docker-compose.yaml here. The relevant Docker-compose file will be used by Hostinger to pull the relevant Docker images from DockerHub and run them on Hostinger. So I've already pushed the relevant Docker images to DockerHub. One image that defines the infrastructure for the Docker container that encapsulates the React functionality, the front-end functionality for the Magic Stream application, and the other image that defines the infrastructure for the Docker container that encapsulates the server-side functionality. The server-side functionality is denoted by a Web API component written in Go. I would encourage you to check out this free course, but as I say, you don't actually need to go through this course to follow along with this video, but it will give you more of a background into how this application was developed. So you don't have to follow along with this video, but if you want to see a detailed demonstration of how I built this application, please check out the video. The link has been included in the description. This is the repo from where we'll deploy the Magic Stream application to Hostinger. You can see we have the Docker file. If we go into Magic Stream client, we have this Dockerfile.prod file here within the React component code. This Dockerfile.prod defines the infrastructure for the Docker container that encapsulates the React functionality, the front-end functionality. And if we go into the server component, you can see we have a file of the same name. This Dockerfile.prod file defines the infrastructure for the Docker container that encapsulates the Web API server-side functionality, which has been written in Go. Then if we go to the root, which is here, we have this docker-compose.yaml file. Here, this file automates pulling the latest version of the relevant images, configuring the relevant environment variables, and launching the relevant Docker containers, which will be done on Hostinger. So let's deploy the Magic Stream application to Hostinger by simply pointing Docker Manager at the relevant docker-compose.yaml file contained within the Magic Stream Mastery repo and clicking the deploy button. So I'm going to log on to Hostinger. So let's go to my account here. I'm just going to log on. So I've just logged on to Hostinger and I'm on the home page. You can see here at the bottom this section with the header VPS. So this denotes my VPS. So this denotes my virtual private server installation right here. So to get to the Docker Manager facility where we'll be able to deploy the Magic Stream application to our VPS, let's click the Manage button here. Okay, I'm just going to skip this. So to get to the Docker Manager facility where we'll be able to deploy the Magic Stream application to our VPS, we've clicked the Manage button. And you can see now we have a new panel presented to us on the left here. Within the panel, we have several menu options. The one that we are interested in is labeled Docker Manager. So let's click that. We have a number of options presented to us here. But we want to click the menu option, the sub-menu option labeled Project. So let's do that. Okay, so please ignore this installation. This installation here is my N8N installation, which actually runs in a container, in a Docker container. So it's a self-hosted implementation of N8N, which is hosted on Hostinger. But please ignore that. We're not going to be dealing with this in this particular video. So let's perform the installation of the Magic Stream application. So to do that, let's firstly click this button drop down here labeled Compose. And you can see we've got a number of options here. Compose manually, compose from URL, one-click deploy. I'll explain what these are later. But for now, we want to focus our attention on compose from URL. So let's click this option, compose from URL. And you can see here we're presented with a form, one labeled URL, one labeled project name, and the header is compose. Paste your GitHub, GitLab, or any Docker Compose file URL to deploy your application. We'll set everything up automatically. So this is the beauty of this. It's just going to do everything behind the scenes. It's going to abstract away all the complexities of the deployment automation, and it just makes our lives a lot easier in terms of deployment. So let's do that. Let's get the URL for the Docker Compose file here from Magic Stream Mastery repo, but we want the raw URL, not this URL. So to do that, we click this raw button here, and then we can just copy that URL from the address bar here within our browsers, go back to Hostinger, go back to Docker Manager, and let's paste that URL here. Okay, excellent. And you can see it's defaulted the project name. It's chosen a project name for us. Of course, we can update that to whatever project name we choose, but let's just stick with the one that Hosting has chosen for us. And then we just click deploy. Okay, and you can see we've got an indicator, a progress indicator up here showing us the progress of the deployment. Great, and it's actually done that deployment. And you can see how we've got various options. If we click this, we can actually update the containers. We can stop and start the containers. We can view the logs, and we can delete them if we want. We can uninstall the containers, but let's view the logs here. Okay, so we've got a lot of status in these logs, and the installation is actually not complete at this point because we need to configure several environment variables. As I said earlier, this is a fairly complex web application, so it does depend on certain environment variable values. If we go to YAML editor here, you can actually see what I mean. So our Docker Compose file here is pulling in, for example, this OpenAI API key from, locally it would pull it in from a .env file, but we need to actually configure that on Hostinger so that those environment variables are available to our Docker Compose file. So it pulls in the relevant values before it runs the files. We've run the Docker Compose file, but the installation is not complete at this point because of these environment variables. So it does involve another step where we need to configure these environment variables. And you've got this for cause, allow origins so that the server-side component allows the client-side component to connect to it over HTTP. So this is what this allow origin setting is here. And you can see API host IP. That's the IP address on which the server-side code will be running. So we need to configure all of these settings. And we need to configure these because we could be running this in a staging environment, a test environment, and settings like this could be different on each of these environments. So that's why we have this configuration. And on our local environment, this is just, for example, localhost. So it's configured as localhost in our local development environment. So we need to tailor this variable's value to the name of our VPS or the IP address of our VPS. Either one will work, but I'm going to use the name of the VPS, the virtual private server, my virtual private server in this particular case, and you'll see that in action in just a bit. So let's set up our environment variables. Okay, and you can see we've got our web container and our API container. So with this visual editor, this visual interface, we can set up our environment variables. You can actually add more containers here. You can edit the configuration of your existing containers. You can see the port that the client's running on is port 8081 mapped to port 80 because the relevant Docker file for the image exposes port 80. It's using Nginx. Nginx is actually hosting the client React component. So it's exposing port 80, and here we are mapping port 80 to port 8081. So this container will be listening on port 8081, and you can create volumes so that data can be persisted through volumes. And it depends, container dependencies, it depends on the API, the code written in Go, which is the other container. Let's go back here. Okay, and we're going to go to Visual Editor here, and we're going to add the environment variables, which will be pulled into the Docker Compose file before it runs Docker Compose. To make life easier for us, I've recorded the relevant environment variables here so that we can just copy and paste the relevant values into the relevant fields. So let's create our environment variables, and it's just a case of hitting environment here, plus environment, and the first one is called secret key. So let's copy that there, secret key, and its value is your secret key. And let's paste that there, and that's done. Let's go to the next environment variable, and this one is refresh token secret key. Let's paste that. The name is refresh token secret key. Let's paste that there, and let's paste its value here. And let's do this environment variable, OpenAI API key, and let's paste that here. That's the name of the environment variable, and this is the value. This is the API key. This won't be valid when you go through the course, by the way, so you will have to create your own OpenAI API key. This video here. This video explains how you can go to OpenAI and get a valid API key. Okay, so I'm going to copy this API key to the relevant hosting environment variable that we're setting up here. OpenAI underscore API key. Got that there, and you can see its value if you click the I icon within the field. Anyway, let's plus environment, and let's do the API host IP. So this is the IP address, but we're using the name of the actual VPS here. You can use either the IP address, and you can find that value on Hostinger, the IP address of your VPS, but I'm using the name of my VPS, which will also work. So I'm going to paste that there. And then let's do allow origins. This is for cause, so that the server component, the Go code, the Go Web API component, allows the client, which is running on port 8081, to connect to it over HTTP. So let's paste that in there. And that is our environment variables done. And we can make sure that they are correct, can view them. And I think that's it. I think that's good. And I think we're ready now to deploy. And you know what? Now that we've set up the environment variables, you can actually see that it's just a case of clicking deploy. So it's a one-off setup where the most complicated part of it is really setting up the environment variables, which is dead simple. So the order of operations is you first connect to the relevant Docker Compose file, the YAML file hosted within your repo, and then it saves it to Docker Manager. So you can actually see it here, and you can even edit it. You can edit your file and do a subsequent install if something goes wrong. And you can see now our environment variables are there in the right panel. And now we're ready to deploy, and this is actually the last step. This is all it takes to deploy a fairly complex full-stack web application. So if I hit deploy, you can see now it's deploying the application. And then any subsequent code changes, you could set up a CI/CD pipeline, and any subsequent code changes that you make, for example, on your local machine, your dev environment, now that you've done this one-off setup, it's just a case of hitting that deploy button. That's it. So it's deployed it successfully. And if we go to view logs, let's go to view logs. You can actually see what's happened there. You see it's listening and serving HTTP on port 8080. That's the Go code. And there's some status output for the client, and everything looks good here. And let's see if it's actually worked. Let's see if our application has been deployed. So let's open a new browser window here, I'm going to include my server name followed by port 8081 where the client is running and click the enter key. Look at that. The application is running successfully. So let's log on. I've included some sample data within the database so we can log on automatically. So bobjones@hotmail.com and the password is capital P, password, and then 1 exclamation point. Let's log in. Excellent. And if we go to recommendations, you can see that these are the movies that have been recommended for Bob, and this recommendation service is powered by AI. Please check out this course for all the details. Okay. So that has been deployed successfully, and we could, test it further by watching a movie. Great, look at that. Excellent. Rick Dalton. Cool. There we go. Once Upon a Time in Hollywood. Excellent movie. And they can now stream it from our Magic Stream service. That's awesome. Okay, let's go to the home page, and you can see all our movies here. And please note that if we go to the YAML editor, we can see the Docker Compose file here. Note that for the server-side container, we have a MongoDB _URI environment variable configured within the Docker Compose file, and that's pointing to a MongoDB database hosted on Atlas. So if you go to this course here, I do explain how you can create a MongoDB database on Atlas for free and import the relevant data. And the relevant data is actually included here within the Magic Stream repo. So if you go to the Magic Stream repo, you'll see, you can see here we've got Magic Stream seed data, and you can just import the relevant data. Each one of these files represents a collection within the MongoDB database, and you can just import the data from within those files, and then you'll get a similar display here of all the relevant movies, and you'll be able to play them and do everything else and log in as Bob Jones and test the application, play with the application yourself. Excellent. So we've deployed Magic Stream. That's all it took. I'll show you how this can actually serve us as a CI/CD pipeline now. Now that we've got our application installed, we could actually push a change to our Magic Stream repo. And this isn't the one I want. I want to go back now to the Magic Stream mastery repository. So the Magic Stream mastery, this is the one that contains all our deployment information. I just want to show you this. I've created this GitHub action, and you don't need to know all the details of this, but basically what it does is it responds to an event, a push event from my local machine, where I push changes, code changes from my local machine to this repository, and which triggers build and deploy. And what this does is it logs into DockerHub. So it builds the relevant image from the provided Dockerfiles, DockerHub, dockerfile.prod for the client and the server. It builds the relevant images and it pushes them, push equals true, to DockerHub. And then when we run Docker Compose from Hostinger by hitting the deploy button, it deploys those changes to Hostinger. And I'm going to show you that now. So you can see here on the home page, we don't have anything above this first movie here. So we don't have any headers or anything. What I'm going to do is just put a header above there. So it will demonstrate how we can propagate changes through a CI/CD pipeline using Docker Manager. Okay, so I'm going to go here, and I'm going to go to the home component for the client code. So Magic Stream client, the React component. And I'm just going to, you can see now, I'm going to add a heading. So H2, you can see now it's checked out the code. It's saying that there's an issue, but that's because we haven't completed the code. So H2 there. And I'm going to just put a heading in there, Magic. So above the movies, you'll see this heading, Magic Stream Movies, like that. And I'm going to save that. Now it's checked that out. saying that it's modified that file. So we need to just check that in, and that will trigger the GitHub action. So I want this to be git bash, this terminal. So I'm just going to go to git bash here. Okay, and now we're ready to check that code in. So with these commands, git add dot. So we're adding it locally, all our changes firstly to our local repository. And then we're going git commit. We're committing our change, and we must include a message here. -m, and I'm going to say minor heading change to home, home page, like that. Let's press the enter key. Looks good. So let's now push that change through to our Magic Stream Mastery repo, which will then trigger our GitHub action, which will build the relevant images based on the relevant Docker files and push them to DockerHub. So git push, enter, and now all of that magic is going to happen behind the scenes. Excellent. And if we go to Magic Stream Mastery here, and we go to actions, we can actually see the progress. So you can see here the progress, minor heading change to home page. That was our message, our commit message. And this will spin around, and if it completes successfully, it will present us with a green tick. And if it doesn't complete successfully, it will present us with a cross, a red cross like that. So now we just have to wait for it to work its magic. Excellent. And that has gone through successfully. Okay, great. That has been successful. Now, if we go back to Docker Manager, all we need to do to pull those changes from DockerHub down to Hostinger, which essentially means running this, our Docker Compose file here. All we need to do to execute our Docker Compose functionality here, which pulls the relevant images down to Hostinger and runs them as containers. All we need to do is press the deploy button now. So let's do that. And we can see we've got our indicator here, our progress indicator, as it runs our Docker Compose instructions, pulls the images down, and launches the relevant containers, project deployed, and that's been done for us. Super efficient, very impressive. And then you can see, if we refresh our browsers, you can see Magic Stream Movies. It's propagated through from our development environment through to our live environment, hosted on our VPS on Hostinger. I just want to make the point that you'd ordinarily want to include automated tests in your CI/CD pipeline so that your code only is deployed if the automated tests run with successful results. I haven't included test automation or HTTPS for security in this deployment functionality deliberately so as not to convolute the overall process. My focus for this video is on Docker Manager, Dockerfiles, Docker images, Docker Compose, and of course the automation of the deployment process in general. So let's continue looking at Docker Manager. If we look at this facility here, you can, for example, add a container. We're not going to do that, but you could add a container to your container network here. This makes it considerably easier for us, gives us a convenience, and then of course you can configure the relevant environment variables there. And you can compose a network of containers that work together for your application from within this visual interface here. So that makes it super easy. So let's look at some of these other compose options here. You've got compose manually, which is what I just showed you here. This provides you with a visual editor where you can actually add containers to your container network. You can see the workflow here. You've got YAML editor, and you can write your Docker Compose file for spinning up your relevant containers here. So it really is a convenient visual editor provided by Docker Manager on Hostinger. Let's get out of that. And then you've got, if we go to compose, you've got compose manually. We've just demonstrated in a fair amount of detail how to use compose from URL. And then you've got one-click deploy here, and I'll just explain what this is here. One-click deploy in your hosting a VPS lets you install and run ready-made app stacks like N8N, WordPress and Docker, etc. with a single action instead of manual setup. Behind the scenes, it uses a predefined Docker Compose file for that app, images, networks, volumes, environment variables. Pulls the necessary Docker images and starts all containers automatically, applies sensible defaults so you only adjust a few settings like domains, passwords, ports, instead of configuring everything from scratch. So now that we have deployed our app the easy way through Docker Manager, I'm going to show you how it could be done the hard way. So here we are going to go through building the Docker images from scratch. We'll build a Docker Compose file to run our containers on our local machines. We'll create a development version of the Docker Compose file where we can run our Docker containers in watch mode so that we can debug our code in real time with a hot reload feature. We'll create production versions of our Docker images and push them to DockerHub. We'll create a production version of the Docker Compose file. We'll then perform a one-time setup on Hostinger using the terminal. You could actually go into a terminal here, which Hostinger provides us with, which is going to be a lot more difficult to do because you're actually running commands within a terminal rather than using a graphical user interface that Docker Manager provides us with. But I'm going to show you how to do that in the next section of this course, because it will give you a deeper insight into Docker containers, Docker images, Docker Compose, and all the various under the hood functionality that occurs when deployment is automated. We'll then perform a one-time setup on Hostinger using the terminal provided to us on Hostinger, where we'll create a .env file that will contain the relevant environment variables. We'll then write a GitHub action that will run every time we push code changes from our local machine to GitHub. This allows us to make code changes and pipe these changes directly to the production environment on Hostinger from our development environment hosted locally. So the changes propagate through to live from our local development machine without causing any disturbance to the user. When the GitHub action is triggered, it will build the Docker images and push them to DockerHub. Using SSH, our GitHub action will then pull the latest images from DockerHub to Hostinger. The containers will then be launched on Hostinger and the old containers will be destroyed. So in effect, we'll create a CI/CD, continuous integration, continuous deployment pipeline. You'll just see how easy Docker Manager has made creating a CI/CD pipeline when we go through the steps using the terminal. I'll now demonstrate a more detailed, time-consuming way to do this, so you can see how much time Hostinger's Docker Manager will save you when it comes to deploying your applications. But you'll also gain a deeper understanding of what is going on under the hood, as it were. The main point of going through all of the manual details in this section of the course is to give you a deeper understanding of Docker images, Docker containers, and the automation of deployment using Docker Compose and a GitHub action. Docker Manager abstracts away a lot of the complexities of the deployment process, which is excellent for efficiency. However, I also want to give you a deeper understanding of what is going on under the hood. Just to be clear, I'm certainly not advocating for going under the hood and creating all the details yourself unnecessarily whenever you want to do a deployment. The whole basis for technological evolution is to make us more efficient and hopefully make our lives a little bit easier. The Docker Manager tool provided by Hostinger will save you a lot of time and increase your efficiency. But let's go under the hood a little bit to gain a deeper understanding of Docker images, Docker containers, and Docker Compose. So before we start this, if you're following along, I just want to make you aware that you can reference the code, because I'm going to actually step by step create another version of the Magic Stream application in this repo here, Magic Stream app. So in this next section of the course, you can reference the code on Magic Stream app if you get stuck while following along. Okay, and now let's initialize everything. So now that we've created through Docker Manager, we're going to create the same thing, but the hard way through terminal, just so you can gain a deep understanding of what's going on under the hood with deployment automation. So what I'm going to do is I'm actually going to uninstall this Magic Stream Mastery installation, these containers, Magic Stream API, Prod, Magic Stream Web, Prod containers, And I'm going to do that through this utility here. I'm just going to click the three dots here and hit delete, and we're now ready to, well, here's our indicator. It's deleting those containers. And now we're ready to create our deployment automation from a clean slate. And we're going to do it through terminal this time rather than Docker Manager. And you'll see by doing this, you'll gain a deeper understanding of the relevant components involved in the automation process. And you'll see how much time Docker Manager can actually save you. So let's get right to it. So the first thing we're going to do is we're going to navigate to GitHub. So I'm navigating to where my GitHub repository is for the Magic Stream repository. And here it is there. And we want to clone this repo on our local machine. So to do that, we can just press this button here and then download zip, and it'll place it within our downloads folder. Great, so that's downloaded. So I can navigate to the folder like that, and then we want to copy the contents into a designated directory, a working directory on our local machine. So I'm going to create that within C, Dev, Golang. You can see I've been playing around with various versions of the Magic Stream application. So we're going to create a new version of this. So I'm going to create a working folder here within the root folder, the Golang folder, because it's kind of a Golang application. It's a Golang React application. React, of course, on the client side, and Golang on the server side for the web API functionality. So anyway, I'm going to create the folder, and let's name this Magic Stream App. Keep things simple and differentiated from all the other Magic Stream versions that I've been playing around with. Then I'm going to go into that folder, and I'm just going to copy the contents of what we've downloaded from GitHub into this new folder that I've created here. And of course, if you're following along, just do a similar thing. Great, so now we've got all the relevant files. We can load up Visual Studio. Okay, and I'm going to open a folder. Okay, so I'm going to open a folder, that folder that we've just created. So Golang, and then where is it? Magic Stream App, there it is. Great. And we want to open that. So we select the folder, and we're opening the application, the Magic Stream App application within Visual Studio. And it's of course very simple to load up a project within Visual Studio. And now we can get to work on our application so that we can run it within Docker containers. So firstly, you'll notice obviously we've downloaded the client here, and of course it doesn't have all the relevant Node modules. Of course, the React application relies on having Node installed for all the relevant dependency modules. And of course, that's not stored in the GitHub repository. So we want to run npm install. So let's go to our terminal, navigate to client, Magic Stream client. Oops, so it's Magic Stream client. Great. And then we want to run npm install to install all the dependencies. And this is, of course, so that we can firstly get the project working on our local machines before we containerize the relevant components. So containerize the React functionality as well as the Golang functionality. Okay, it seems to have gone okay. So that's installed all the relevant Node dependencies that our application needs, our React application. Note that I used Vite to actually create this project. There will be significance to why I've mentioned Vite a little bit later, but for now, let's just continue setting up our local environment. Right, so you're probably going to want to install MongoDB. I'm not going to go through all the instructions of how to install a local version of MongoDB because I've already done that in a previous freeCodeCamp course. So what I'm going to do is I'm going to go to the freeCodeCamp YouTube channel here. Okay. Let's go to videos. And it is the video that I'm concerned with here where I take you through a step-by-step creation of the code for the Magic Stream application. So it's this particular video here you want. And if you look at the chapters that are detailed within the description, you can find where I'm setting up MongoDB on a local machine, and just follow those instructions to guide you through the process. So you want to install MongoDB and you want to install a UI utility called Compass, but that's part of the installation process, which I guide you through this course here. Okay, excellent. So let's click off that there. Great. So I'm assuming now you've got the MongoDB Community Edition installed on your local machine, your development machine. And the next step is to create the environment variables. You see the environment variables on which this application depends will not exist, obviously, within the GitHub repository. So we need to manually create that. So that's the next step. And we're going to create the .env file, which stores our environment variables within the client application. So if you select this folder here and go new file, let's name this .env, the standard naming convention for a file that will store the environment variables. To save time, I'm just going to copy the environment variable from a file off screen into my .env file here. So you can just add this particular environment variable. So we're just trying to get the application initially running on our local machines. That's all we're doing here. Great. So we've got all our node modules, our dependencies. We've created the .env file for the client. And we need to create another .env file, but on the server. And this has significantly more environment variables. So anyway, so we do the same thing. We select the root of the server-side code here, and we hit this icon for new file, .env. And just to save time, I'm going to copy and paste these environment variables from a file I've got off screen here. So you can just essentially mimic what I've got here. And don't worry too much about this open AI API key field here. This will mean that you'll have to go to the OpenAI website and create yourself an access token. You'll have to create an account on the OpenAI website, and you will be charged, I think, $5 minimum just to get started, but your credits do last a long time, so it is worth it. And then you'll be able to use the AI features within the Magic Stream application. I'll explain this a little bit later, what I mean by this. So this is just my OpenAI API key here. This won't be valid when you watch the video. So we've got all these environment variables configured here. And this is for the server side. So initially for the MongoDB URI, it's pointing to the MongoDB database that we're setting up locally. This is what this connection string means. So it's going to connect actually from the container to a local version of the database that we're actually going to create now. But we actually want this one because we're going to run this locally first off. So that will connect. This is the connection string appropriate to connecting from a container, a Docker container, from the Go component stored in a Docker, running within a Docker container, to a local instance of a database that we're going to create now that will run on your development machine. So, and this is just the local connection string because we're going to be running it locally, but we'll use this connection string in the next step, but I'll elaborate on that when we get there. So MongoDB URI equals to that there. And now we can load up Compass, which provides us with a UI so that we can create MongoDB databases, manipulate the data, import data, etc. So this is Compass here, and you can see I'm connecting to this instance of MongoDB, and you can see I've created several databases, and this is the Magic Stream database that we're going to create now, but we're going to create another instance of it. So if you just follow along with me here, let's hit the plus icon here, and our database, we want to call it Magic Stream App, like this. And the collection name, the first collection name will be movies. Okay, like that. And then we go create database. So we've got one collection at the moment, and we need to create these other ones here. So I'm going to do that quickly. I'm going to create another collection named genres. Excellent. Create another collection named rankings. And another collection named users. Like that. Excellent. And now we want to import the relevant data. So to import data, we can hit this button, and we're going to import the genres first. Okay. So we can actually import them from this directory, but I'm going to take you to the new version that we created of the Magic Stream application in Magic Stream App there, and you'll see, because you've cloned the repository, you'll see a directory called magic-stream-c data. If you go into that, you can simply import the relevant data for each of the collections. So let's import genres.json. Excellent. Import. So genres, all the data for genres. You can see thriller, fantasy, western, all being imported. And then movies. This is the very important collection, contains all the movie information. It's a movie streaming application, so obviously the movies collection is extremely important. So anyway, let's double click on that. Import. So we've got all the movies information here, and let's import the rankings data here. Import. We've got all the rankings there, and then lastly the users. These are just fake users I've set up, default users, so we can get started immediately and log on to the application. Bob Jones, Sarah Smith, just fictional made up users. Okay, so now we've got our database set up, the MongoDB database set up, and we've got all the collections populated with data. We've seeded the database. Great. One thing I need to change is the database name. So this is Magic Stream App. Let's just confirm that. If we go to Compass, we've got Magic Stream App. That's our database. So we want this to be Magic Stream App, because that's the MongoDB database that we've created using the Compass utility that was installed when we installed the community version of MongoDB on our local machines. Okay, and you need the connection string to be set to this, because we're running an instance of MongoDB locally initially. We just want to get the application working first. So I think we're ready to actually run the application. I think that's right. And we're just doing this before we containerize the components, so the client and the server. So let's run the server side first. So I'm going to create a new instance of the terminal here. We're using PowerShell here, and let's navigate to the server application, Magic Stream server, like that. Okay, we're in Magic Stream server, and then the command to run our server-side code is go run dot, like this. Okay. Okay, excellent. So it's listening on port 8080, and we can actually test that that is running appropriately and connecting to our database by navigating to localhost. We want port 8080 here, and then we want to test the movies endpoint and see if our data comes back. And you can see all our movies stored within our MongoDB database have been returned to us. That's the users. We want movies. So we've got the Shawshank Redemption, Once Upon a Time in Hollywood, etc. And that data is being returned to us in a rather ugly manner at the moment from this movie's endpoint. And we use this data obviously on the front end and appropriately display them on the home page. But we can see that a little bit later. But that is working. It's connecting to our database. We've got the Go code up and running. It's all looking good for our local environment. Okay, perfect. So let's go out of that. And we can stop running this by simply going Control-C. So we're canceling out of that, clearing the screen. And then let's go back to the client folder here. And I don't know why I did that. I should have kept it running. Go run dot, because we want to run the client, and you can see all the movies displayed on the home page. So, right. Okay, it's listening on port 8080 again. Let's go back to the client and let's run the client. And its command for this is npm run dev, because I actually used Vite to create the React application, the React component for this application. So the appropriate command to run the React component is npm run dev. Press the enter key. Excellent. Okay, and it's listening at this location on our local machines. So let's go there. We go there, and now it should display all our movies for us, assuming nothing has gone horribly wrong. There it is. Woohoo! So we've got Magic Stream running locally now. And can we log in? I think we can. Let's log in as Bob Jones at hotmail.com. And that's one of our fictional users, Bob Jones. And there it is. We're logged in. And this is the AI feature that I was telling you about, which you won't be able to run unless you have an OpenAI key. So if we go to review, basically what it does is it takes an admin movie review and it reduces it to one word, summarizing the sentiment behind the actual movie review. So I love the acting in this movie. It was absolutely sublime. That goes off to OpenAI, and OpenAI uses its intelligence to produce one word which summarizes the sentiment behind the movie review. And in this case, that sentiment is excellent. Okay, so I think that's good enough. We've got it all running locally. That's great. The next step now is we want to containerize the client React component and the Go component. Excellent. Let's log out. Done. We've got the Magic Stream app running successfully on our local machines. We've just proved that, so we're all set up locally. But now we want to containerize the client-side React component as well as the server-side Web API component, which is written in Go. Okay, so to do that, we need to create two Docker files, one on the server and one on the client. So let's start with the server one. So let's go to this folder here and let's create a file within the root of the server component, Magic Stream server. And let's hit this icon here to create a new file, and let's call this Docker file. So this is a convention for the name of a Docker file where we are going to establish the image for our server-side code. The image is obviously separate from the container. The image defines the environment for the container, if you like, and the commands that need to run to get the application running within the container. And of course, the container is like an instance of the image, which is what actually runs when you run a Docker image. So the container is the thing that actually runs in memory. The image is the declarative information about what you want to run within that container, essentially, and all of its dependencies and that sort of thing. So we've got Dockerfile there, and that's all it needs to be is Dockerfile. That's a naming convention for a Docker, for a file that contains an image definition, if you like. And we're going to create the image definition now, but I've actually already created that off screen. So I'm going to just, to save time, copy that here. And this is essentially it. That is the definition for our image. Each line represents a layer within the Docker file. And this particular layer here is using a lightweight Alpine Linux image with Go 1.24.2 installed. So this will allow us to run Go within the relevant Docker container. Work dir/app sets /app as the working directory inside the container. So this is where we're going to be copying all the relevant files to, for example. So here we have a copy command. So copy go.mod, go.sum, / copies Go dependency files into the container, and then run go mod downloads the Go dependencies, and they are cached if unchanged. So what that means is if nothing is changed the next time you run the image, it will actually run this layer, but it'll run the cached version of the layer. But if something has changed regarding this particular command, it will invalidate the cache and rerun it. It will re-download the relevant dependencies. Copy ... copies the rest of the source code into the container, and then expose 8080 documents that the app listens on port 8080. And you'll see when we actually run the image as a container that we will need to map the exposed port to the local host port so that we can run the application. We can run the server-side code on a particular port. So we'll be mapping port 8080, which is exposed from within this file, the image. We're documenting that it should listen on port 8080, and we're going to map 8080 to 8080, but we're mapping the container port to the host port. We're mapping it to a port on the local machine, which also will listen on 8080, but we'll look at the details of this in a little bit. And then we're actually running the Go component. So we've set up the environment here basically, and this is running our actual application, the server-side part of the application. And you can see here we're using the cmd command within the image to run main.go, which is the entry point for our server-side component, the web API component written in Go. Excellent. So we've got the image definition set up here. So now we want to build the image based on all of this information. So to do that, we need to navigate firstly to the root of the client where our Docker file has been created. The root of the server, sorry, not the client. So we need to go to the server part here. And I'm still running it, so I'm just going to go cancel out of that, clear the screen, and Magic Stream Server. And now we want to create the image, create the actual image. So to do that, we use a particular command. So to create the image, we go docker build. So the first part of creating an actual container is to build the image. And that's what we're doing here. We're building the image. Docker build, then -t, then the name of our image, the name that we want our image to have. So Magic Stream API. And then this is the tag, which is actually the version we want for the image, which is just 1.0.0. So we're able to version our image. And then we need to include a dot here, which means we are using the current directory as the build context where the Docker file resides. So let's go through that. So Docker build builds the Docker image. And then we've got -t, which tags the image with the name Magic Stream API and the version, which is following the colon here. And then we've got the dot, which means that it uses the current directory as the build context where the Docker file is. So in short, it builds the Docker image from the current folder and names it magic-stream-api : 1.0.0. 1.0.0 is the version of the image. So we've got our command there in place, and let's build our image. And that's it, building our image, our Docker image. And we can actually view that. As I said earlier, you should install Docker Desktop. You need to install Docker Desktop in order to run these commands. So we've got Docker Desktop here. You need to actually install Docker Desktop in order to run these commands. But it also provides us with a graphical user interface where we can run our containers, stop our containers from running, see what images we've got created on our local machine. We can delete those images if we need to. So this provides us with a user interface where we can actually see what's going on in terms of our Docker images and our containers. And you can also start your containers, stop your containers, remove your images, and so forth using this graphical user interface here. Okay, so if we go to images, we've got Magic Stream API and we've created that image. You can see it there. So now we can actually run that as a container. Okay, we need to make sure that our environment variables are set up correctly. We need to make sure that MongoDB _URI is changed because we're going to run this as a container, and this is the connection string we need if we want to still use that local version of the local instance of that particular database, that MongoDB database. So what I'm going to do is I'm going to comment this out using the hash symbol within the relevant .env file and comment this one in. And this, as I said, allows us to connect to the local version of the database, the MongoDB database, the local instance, rather than one that's running in a container, for example. So we want to connect to the local instance, and this is how we can do that. We've set up a local instance, but later on, we're going to run the MongoDB database within its own container. But for now, this is how we need to connect to the MongoDB database from our server-side code. So this is the correct connection string, and we've got the database name here, Magic Stream App. Great. And now to run our container, we have a particular command that we can run, and it goes something like this. Docker run, not ton, run. Docker run -d, because we want to run it in detached mode, so it runs in the background, and then --p, and now we do our port mapping as discussed earlier. So we want to map the port. We want to map the container port, which is 8080 to the host port, which is 8080. So this means that on our local machine, we can access the container, the code running within the container, where it's listing on port 8080. So we must map the containers port, which was defined within our Dockerfile image here, expose 8080, and we're mapping that, the container port, that's the container port. The one on the right is the container port. That's the container port, and that is the host port on the local machine. So in order for us to access the functionality of this particular API, we want the host port to be listing on 8080 and mapped to the relevant container, so that we can make the relevant HTTP requests to the container, which is obviously within that container, our Go code is running. Our web API code is running. So we want to name our container. We go --name, and let's name our container Magic Stream API. Magic-stream API, like that. Just going to move this over a bit. And the thing we need to do also is we want to inject in our environment variables from the .env file that we created earlier. And to do that, you go --env like this, and -file, and then .env, which is the file that contains the relevant environment variable settings. And then we want to derive this from the Magic Stream API image, which, as we verified through Docker Desktop, is now running on our local machine. So magic-stream API :1.0.0, which is the version of our image. And then we should be able to run that. That looks good. Docker run -d, running in detached mode. --p, mapping the port appropriately. --name, we're naming the container. --env -file.env, we're reading the environment variables into the container. And then Magic Stream API :1.0.0, which is just the name of the image, where we're deriving our container from. So let's press the enter key. Unknown flag -pp. Okay, so I'm assuming, let's just copy and paste that. I think P must only have 1 dash. I think that might be what the problem is. So let's try that. Let's remove a dash there. Okay, let's try that again. Okay, perfect. And that has worked. So that was the problem. So that command is not dash dash p, it's dash p, and where we're mapping the container port number to the localhost port number. And this is the correct result we want to see, and that is the ID of the container. Okay, if we go here, we can see our image. We can see here our container, and that is the container ID. So yes, that is the container ID. That's the container we've just run. And now we can test that our container is running correctly by navigating through our browsers to localhost, and we want the port, which is 8080 movies, and we can see that is working correctly. So our container is up and running. It's exposed on port 8080, so we can make a HTTP request to our container, and it returns the relevant movie data. So that's working perfectly. So we can see here we've got our images, we've got magic-stream-api 1.00, and we've derived, if you like, a container. We're running a container from that image, if you like, which is magic-stream-api, and that's its container ID, which has been generated to uniquely identify the container. Great, so we've created the container for the Go code from this image here. Now we want to create a container for the client, the React code here. So it's the same process essentially. We need to create a file, a Docker file, which defines the image that we want to create. So we're in the root of the client here, and we are going to hit this icon to create a new file, and we follow the convention, Docker file, the naming convention. You can see it's got a whale there now, a whale icon, which denotes that it's a Docker file. Great. I've actually already created the Docker file. Just as before, I'm just going to copy and paste that in to save time. So here's the image definition for the React component, the client container here. So I'll get to explain all of this a little bit later, but for now I'm going to comment this command out, and I'm going to comment in this command. This is a more simple version, and I'll explain all this a little bit later, and we don't need this for now either. Okay, so I'm going to comment that out. So let's go through this layer by layer or line by line. Remember, each of these lines represents a layer in the Docker file. So from node :20-alpine, this uses a lightweight Alpine Linux image with Node.js 20 installed. So we're creating an environment that's from an existing image. So it's based on an existing image. That's what this from means here. From this image, we're deriving another image. So you could say it's inheriting all the layers from this image before creating the image that we're creating with this particular Docker file. So that's all we're doing here. From node :20-, then we're creating the work directory. Sets app as the working directory inside the container. Then it copies the package JSON and package-lock.json file. And then we're running npm to install all the dependencies, the node dependencies that our React application requires. And then we copy ... copies the rest of the application files into the container. And then, as before, when we expose port 8080 for the server container, we are exposing 5173 for the container that will be derived from this image. So we want to expose 5173, and then we've got the command here, which is just running our React client. You'll recognize npm run dev because we ran that when we were running it locally, i.e. outside of a container. And so this is essentially what we're doing here with this command layer here. So at the container's start, the command starts the dev server and binds to all the interfaces. Basically, that's what that command is doing. Okay, so we're now at a stage where we can build our image, and we do that as before. We use this command, docker build. Remember, all these commands are available because you installed Docker Desktop. So you got docker build, then -t, and then we can, after the -t option, or switch, or whatever you want to call it, we can name our image, and we want to name it Magic Stream Web, magic-stream-web, and let's give this a version of 1.0.0, and then you must also include the dot afterwards, which uses the current directory as the build context where the Docker file is. So that's what that dot represents, and let's press the enter key to build our image. Okay, and that's looking pretty good. Gives you the status update as it builds the image. Provides us with status, and it's looking good. As always, we just have to be patient. Shouldn't take too long, because I think we've created a fairly efficient image here. So 2 of 5 layers. It's 5 layers in the image. It's building the second layer here. So it's building the 4th layer. npm install. It's installing all the dependencies for the React application using npm install. Okay, and we're on the 5th layer, and it's copying all the application files, and it's finished with that now. And we're now ready to build our container. But let's just go to Docker Desktop, and you can see, if we go to the Images tab here, you can see it's built magic-stream-web. It's built that image there, and it has its image ID. So now we can derive a container from that image, and we do that through the run command. And I want you to notice something that is pretty cumbersome. The fact that when we're running our images as containers, we have to create 2 separate commands for the client and the server. Ideally, what we would want is one command to run both images. So you've got the client and the server containers running, and they're part of the same network. So wouldn't it be better if we could just use one command to run the entire network of containers? And we can do that using docker-compose, and that's what we're going to do once we've tested running the components individually. We've run the server component and tested it. Now we're running the client component and testing it. We're deriving the client Docker container, and we're going to test. Then we'll be able to test the entire application. The difference between testing it now and when we tested the application before is we were running it on the host computer before, and now we're running the application within a network of containers. We've got a client container and a server container communicating with one another. So they're containerized. And later on, we'll also containerize the MongoDB database. But for now, let's just test the client and the server containerized components and see them working together as one application, one full stack application. So we've done the server. Now we want to derive the client container. And we do that through the docker run command. But later we'll run both containers at the same time using docker compose, and we'll get to that in a bit. So let's just run this container individually, the client container. So it's docker run -p. Remember, it's only one dash. I put 2 dashes before, and it didn't like that. And I'm just going to actually -d first. -d means that we're running it in detached mode, running it in the background. So docker run -d -p, and we want to map the exposed container port to the localhost port. So this is the localhost port, 5173. We want to expose that port, and we're mapping the container port, or the image port, which we expose here in this line, this layer of the image, expose 5153. So we're mapping 5153 to 5153, but this is 5173. 5173 is the port number for the container that's defined within the image here. And then 5173, this is the local host port. So we're mapping the container port to the local host port with this switch here, this option -p. Okay, so we've got -p, and then we want to name our container. So this is --name, followed by the name we want to give it. Let's call this Magic Stream Web. And then we go -env -file like this, because we want to inject in the relevant environment variables from that .env file, which contains the relevant environment variable settings, followed by Magic Stream Web, and this is of course the image from which we are deriving the container. Okay, and that's it, I think. Let's press the enter key and see what happens. Okay, great. And now it returns the unique identifier for the actual container, which means the container is now live, up and running on the local machine. And let's see that. So we've got the image here, and then we've got the container from that image, Magic Stream Web. So they are running. So now we should be able to run the full application. Right, okay, so we've got our two containers running. You can see that here. Magic Stream API, Magic Stream Web, they're running. The downside is we had to run them individually. So once we've tested these containers working together as a full stack application, what we're going to do is create what's known as a Docker-compose file. And what this will do is enable us to run one command, docker-compose up, and it will run both of the components appropriately and run them as a network of containers, basically. Our full stack application is run as a network of containers, which is what we want to achieve here. But you see, we've had to run two separate commands to create the containers for the server side and the client side component. And that's not ideal. And you can imagine if we have several containers that we want to run as a network, you don't really want to be running each container individually every time you want to test your application. So that's the necessity for the Docker-compose file. The Docker-compose file, which we're going to create next, will allow us just to run one command and run all of our containers in a network. And we'll look at that in just a bit. But let's just test what we've done at the moment. Let's load up the browser and go localhost 51. And there you go. So it's all working as expected. Let's just log on with one of our users, Bob Jones. Okay, just for good measure. And there you go. Those are recommended movies for Bob. He likes sci-fi, fantasy, and comedy, clearly. Great. Okay, so the application is clearly working. Excellent. Let's log out. So now we want to create our Docker-compose file. And what I'm actually going to do is I'm going to go to Docker Desktop. I'm going to stop these from running, and I'm going to remove these containers. And this is how you can do that from within Docker Desktop. We want to create a Docker-compose file, and we're going to create that file within the root of the Magic Stream app directory. So let's do that. Let's create a Docker-compose YAML file. It's a YAML file, which is just a format for a file like XML or JSON, but YAML uses indentations and colons. You'll see what I mean when we create this file. So, okay, so we're going to create the docker-compose.yaml file within the root folder, Magic Stream app. Let's do that. Let's hit this icon to do that, and we go docker-compose, and this is the naming convention for a Docker-compose file, and we go YAML. You could also go YML, but let's type out the entire extension, which is YAML. So we're creating our Docker-compose file, and you can see the relevant icon has appeared there within Visual Studio. So it's recognizing the Docker-compose file. Visual Studio is recognizing the docker-compose.yaml file. And I'm just going to copy it in here, just the basics for the file. We'll have to alter a few items within this file, but I'm going to copy the Docker-compose file I've got stored off screen here and paste it in here just to save time. And I'll go through the relevant parts of this file. So this contains the actual containerized image for the Mongo database, the information, the definition for the image, from which we derive a container that contains the MongoDB database, but we don't want to do that right now. So this also seeds the database. I've automated the seeding of the database, and we create what's known as a volume, but I'll go through that in just a bit. We want to create a more slimmed down version for now. So I'm going to remove this DB stuff here. We don't need this either. So we just want the definition for the API component and the React component for now, just so that we can test basic Docker Compose functionality and its significance. This name isn't the same as we've got currently, so we need to just modify that. Okay, and the container name will be Magic Stream Web for the React component, and that's the image that we created earlier. Okay, and depends on, we can remove this because we're not containerizing the database, at least for now. So we can remove that there, and let's alter this name here. So it's Magic Stream API 1.0.0. That's what we named our image, and our container, let's stick to this convention, Magic-Stream-API. Okay, we've got the ports mapping there, and we've got the relevant environment variables. And you can see here, we're actually reading in. So when we use Docker Compose, we want the relevant settings to be read into the containers, like here for the React component, and then all of these settings for the Go component. So we want these environment variables read in when the Docker Compose command is run, and we'll look at that in just a bit. So we actually need to create a .env file, and that's the significance of this particular .env file, is that these settings will be read in and injected into the container when Docker Compose is run. Okay, so now within this Magic Stream app folder, the root folder for our full stack application, let's create a .env file. So let's right click this panel, go new file, and .env is the name of the file we want to create. And I'm just going to copy those in just to save time. Don't worry about the individual settings. I can explain that a little bit later on. And we've got all of these now, all these settings within the env file, which will be picked up when we run the docker compose command. And these settings will be injected into the docker compose file. And in fact, I've made a mistake here. I've created this docker compose file within the server directory. We don't want that, so I'm going to just drag that out of there into the root. Yes, that's where we want it. We wanted this docker compose file within the Magic Stream app root directory. So I've dragged that out there, and it's going to pick up these settings, so secret key, from this .env file when we run the docker compose command, and it's going to build both the web container from the image we created for React, for the React client component, and it's going to create a container for the Magic Stream API image. And you can see that we've got all this detail here. For example, we're mapping the ports appropriately. Here we've got the container name image, but we're putting it in a differently formatted file here. Whereas we're using run to create the containers individually before, now our Docker Compose file will create both the containers in a network of containers automatically. Okay, so we want to, in fact, let's just create a new terminal here, and it's going to default right to this directory, to the root directory where our docker-compose.yaml file resides. And now we're going to derive the relevant containers from their appropriate images by using docker compose. We're going to run a docker compose file. You can see here, if we look at the containers tab, we deleted those containers that we created using the run command, and we're now going to create the containers with one command, whereas we had to create the containers with two separate commands before, which isn't ideal, especially as you scale up your application. You could have multiple containers. Docker Compose is a far more efficient way of creating your containers. We need to change one more setting here, So I'm going to just comment this out here. And we wanted to connect from the container to MongoDB hosted locally. So we're going to be connecting to the locally hosted MongoDB instance that you can see here through Compass in this particular case. And this is the appropriate connection string to connect from a container, the container that encapsulates our Go functionality, the Web API functionality. We're connecting to the locally hosted MongoDB instance here. And we need to change the database name to Magic Stream App. Like that there. And it's going to pick up these settings. This is what this dollar, and then wrapping the relevant environment variable within curly brackets is all about. It's going to be reading those settings from here when we run Docker Compose. Okay. And now we can just type Docker Compose up. One command to create containers for both the client and the server components. Docker Compose up -d. Hopefully the magic will work. Okay, enter. So it's created the network called Magic Stream App default. And that network contains these containers, magic-stream-api, the server-side code, and magic-stream-web, which encapsulates the client-side React code. And if we look in Docker Desktop, we can see we've got our network, which is called Magic Stream App. And if we hit this arrow, we've got these two containers within that network, which has been created through one command. Very efficient. And now if we test our application, let's go to the browser. Does it work? Hopefully. Localhost 513. Kapow. There it is. Look at that. And we're up and running, and all the functionality works as expected. Bob Jones at hotmail.com. And you can log on with password 1 exclamation point with the P capitalized. And let's hit login. And there it is. It's all working, and that's the recommendations for Bob. And you can even play a movie if you want to. Look at this. Streams the movie. Fantastic. Harry Potter and the Sorcerer's Stone.
Your right hand over the broom and...
Very cool. Okay, of course. The Hangover. So our application is working. Fantastic. Okay, so before we continue, I just want to make sure that these containers that we are now running through Docker Compose are stopped. Let's stop that one, stop that one, remove this one, and let's remove the client React container. So we've removed those. And before we continue, I want to fix what can be seen as like an edge issue. Let me just explain this issue. So this does involve altering the code before we continue. So the issue is at the moment when a container is built for the client React component, the environment variable, this environment variable here. So if I go here, no, not that one. If we go into the client.env, we can see we've got this environment variable. Now, currently what's actually happening is this environment variable is being baked into the image, which means when you run Docker Compose, you can't override this setting, which will be a problem when we actually port the containers to Hostinger, because obviously Hostinger is going to have a different setting. It's not going to have local host. We wanted to read the environment variable when we run Docker Compose on Hostinger. We want to read it from this environment variable, which is situated in the root of the application here. So when we run Docker Compose, it will inject this setting into the Docker Compose file. You can see it here. So we don't want localhost. We want the actual server name or the IP address, for example, for our VPS on Hostinger. So in order to do that, we need to alter our code so that this environment variable is not baked into the image for the client React component. So to do that, we're just going to go through a few steps in order to accomplish that. So firstly, we go into this public folder. And just one more thing, the reason we have to do this is because we created the React application using Vite. So this is a problem with Docker, specifically regarding when creating a React component in Vite and wanting to containerize that component, the React component. So to get around it, we go into the public directory here. So firstly, we need to create a new file within this public directory. So let's create a new file, and we want to name this. It has to have a specific naming convention, env.template.js, like this. Press the enter key. Great. And then the actual configuration needs to look like this. So just imitate what I've got here for the configuration for the, oops, called it enc, that's not right. Let's rename that env.template. So it must be env.template.js. And then this is what this file must look like, must contain. So window.__ in capitals env__ equals open curly brackets API_URL : and then we wanted to read that environment variable when Docker Compose is run. And you can see that environment variable here within the YAML file for the Docker Compose file, the docker-compose YAML file. So this is what this env.template.js file is doing. We're targeting that particular environment variable, and you can see that within the Docker Compose file. So what that'll do is it'll inject whatever that setting is there, and we're reading the actual host name from within this .env file here. So we're reading that into the Docker Compose file when Docker Compose is run. And this is how we're able to inject the relevant information when we run Docker Compose, so that this setting isn't baked into the image, meaning we can't override that setting when we run Docker Compose. And this will allow us to easily configure the relevant name of the server when we port it and deploy it to Hostinger. And that's why we're doing it like this. Great. So it just involves a few steps to get this done. So we've got this one sorted. We've done that. The next one is we need to change some code. So wherever we are reading the relevant configuration setting, the environment variable, we need to change that. So let's go to src, and we've just got to change it in two places. So axios config.js, and here we are reading the Vite environment variable, which is this one here. We don't want to read that anymore. We want to read whatever is injected. We want to read whatever the environment variable is that is assigned to API URL here in the relevant Docker Compose YAML file. Okay, so let's go back here, and it's just a matter of changing the code. I'm just going to comment that out. So where it's reading the environment variable, we need to change that to this. Const API URL, like that, equals to window dot and then underscore env in capitals underscore question mark dot and then API underscore URL, like that. Great. And then we can just copy this because we need to configure it in another place. You see, this is for unprotected endpoints, and we have another setting here for protected endpoints that we have to alter. That's within hooks. Use Axios private. So this is for the protected endpoints. Comment that out, and we can paste that in now. So it's reading the appropriate environment variable, so it can be injected into the React container, into the container that houses the React component when we run Docker Compose. So when we're running it on hosting it, we want a different setting injected. And that's why we are taking these steps. And the whole root of the issue is because we used Vite to create the React component. So this is what we have to do when we want to containerize it, and we want the relevant environment variables read in when we run Docker Compose. So this is why we're doing that. So we've changed that now in 2 places. And I know it's a bit tedious to do all this, but unfortunately, this is what we have to do because we created this using Vite. We created this React component using Vite. So we need to include this, the script tag with the src attribute set to /env.js here. Right, and this is very important. We need to change the actual Docker file code. And I don't know if you remember, we initially commented this line of code out here and then replaced it with this line of code so it was more simple. But now we need the more complex line of code here to enable this env.template.js file to work. So we want to comment this out here. And we do that with the hash symbol there. Okay, and in order for this to work here, we need to install a particular package. So to install env sub st, we need to run this line of code here within our image. Right, so that now should be all good to go. Okay, so we've now fixed that configuration issue, but we need to rebuild that image. So let's go to Docker Desktop. And firstly, we want to stop. I'm just going to stop all of these containers. We could just get away with stopping the Magic Stream web container because it's really just the client web container that we want to rebuild, the container image that we want to rebuild. So let's press the relevant icon to delete Magic Stream web. That's the container. We need to get rid of the container or make sure it's not running at least before we delete the image. So I'm just going to delete that there. Delete forever. And I'm also going to just delete the Magic Stream API container also. And let's go to images. And we've got this Magic Stream web image that we want to get rid of. So let's delete this image here. Okay. Delete forever. So that image no longer exists there. You can, of course, use the command line to perform all of these tasks, you know, deleting the container, deleting the image, whatever you need to do. But I find it easier just to use Docker Desktop. Okay, so now we want to build the image from the Docker file. So now we're going to build the image from this code here, which is located in the Docker file that we created earlier on. So let's build the image. And the command is docker build -t magic stream web :1.0.0, and then we must include the dot for the build context. Okay, let's press the enter key. Okay, 5 of 6 layers run, 6 of 6 copy. It's copying all the source code into the container. Excellent. So we're all good there. We've built the image. Let's verify that by going to Docker Desktop. We're in the Images tab here, and we can see it here. So it's built that image. Okay, so we've now changed the various code parts so that configuration now injects the relevant environment variables into the containers, and then we can run Docker Compose. And I'm going to include a specific option just to make sure that no caching has taken place. Okay, so let's go Docker Compose build, and then we want no dash cache. Oops. no dash cache, like that. Press the enter key. Excellent. Now let's run Docker Compose up to run our containers in a network, and then we can test our full stack application. So Docker Compose up, and let's run it in detached mode. Press the enter key. Excellent. Okay, great. So that's all working. Great. And now what I want to do is, if you look at the Docker Compose file, we are currently pointing the Go container, the container that houses the Web API functionality. We're currently pointing it from the container to our local instance of MongoDB. And we don't actually want to do this. We want to containerize our MongoDB database, and then point to the relevant connection string. So that's what we're going to do in this part of the course. And I've also written some functionality to seed the database within the container, and we'll also briefly discuss what volumes are. So in order for the data to be persisted once the database has been modified, because bear in mind we're going to be first creating a blank database within the container, and then as you can see here, we've got all this data seeded, which we did through data importation, but we're actually going to run some code to seed the database when we run the MongoDB database within a container. So firstly, within our docker-compose.yaml file, let's include the relevant code. Okay, so I'm just pasting this in from a file that I've got off screen, which will include the relevant code to house an image for MongoDB. And you can see here, that's the image. It's going to pull that from DockerHub into a container on our local machines. Container name is named Mongo. And you can see we're appropriately mapping the ports here. And here we've got our volume. Now this allows us to persist the relevant data in the database once we've modified the data in the database, once we've inserted data, updated data, etc. And then we've got a health check here just to make sure that we can indeed ping the MongoDB database. And what I've done here is written an extra part in the YAML file, which will run a command that seeds the database here. So what this does is it just runs once and then stops. This is what this container does here. And here's the volume. It's named movies. And you can see here the volume is referenced here. Movies, data, DB. Okay. Great. So this is the code for housing the MongoDB database within a container. And this seed code here seeds the database by running a JavaScript file against the relevant database. And we're going to seed that database within the container by running this JavaScript code, seed data, seed.js. Now we need to include this seed data directory within our application. So let's just go to the root directory here. Ignore this one here. That was where we imported the data from. We need a new directory called seed, and I've already actually created that here. So I'm going to copy that from Magic Stream deploy. Here's the seed data directory, and within it you can see you've got genre.json, movies.json, rankings.json, and user.json. This just contains the data that we want to import for the relevant collections, and the seed.js contains the actual code. Okay, and you can download this directory from my GitHub repository here, Magic Stream deploy. And here it is. That's the seed directory, and it contains the relevant JSON files that contain the relevant data, and then the seed.js file. Now this contains some code that I've written that will run the import. So it imports the data from these files into the database. And because we're using volumes, that database will persist. So, which means that when you down the container, if you like, when the container is no longer running, and then you run the container again, it will remember that data. That data is statically stored. So the data is actually stored on the host computer and not within the container, when the container starts, it mounts that persisted data within the container. So the data itself is actually stored on the host statically. And when the container is run, the MongoDB container is run. So when the container here is run, it references that volume, and that volume can now persist because the data will ultimately be stored on the host computer and not within the container. The container can be destroyed basically in memory. So you don't want the data destroyed within that container when you destroy the container itself. We need to include that seed directory. So I am going to go here and copy this directory. This is from another instance of the MagicStream app that I was using to prepare for this course. And you can download it from here, from GitHub. It's the same directory. Mine's currently exists locally in another instance of MagicStream. So I'm just going to copy that. And I'm going to go to MagicStream app, which is the version of MagicStream that we're currently working with. And I'm going to paste it in here. Seed. Great. So that now should exist within my application within Visual Studio Code. And there it is. Excellent. Let's just double check that we're not running the containers currently through Docker Desktop. So we got the images, containers. Just before we run Docker Compose, we need to make sure that we include this code here. Okay, depends on DB. And DB is this code here, which creates the container that houses our MongoDB database. So it's the MongoDB database can run on this container because we are firstly pulling the image from DockerHub, Mongo, the latest image of Mongo, running the container, and then our volume will be mounted here, which contains our database. And here we're doing a health check to see if we can ping the database. And then we've got this here, depends on DB. So this code doesn't run until the relevant DB container has been started and pinged and the health check is run. And this makes sure that the health check is performed before it seeds the data. And this seed code here only runs once to seed the database with the relevant data. And you can see here the JavaScript code that gets kicked off. And all it does is reads the JSON files into the relevant collection like this. Great. Okay, great. And there's a few modifications we have to make in order for this to work. So you can see here we're calling the database MagicStream app, which is obviously appropriate to this database here, hosted on the local machine, but we're hosting Mongo within a container. And we have called this database MagicStream Movies. The database within the container is going to be called MagicStream Movies. So let's change the name here to MagicStream Movies. Great. And then we want this connection string here because this points to our local database where MongoDB is hosted directly on our host machine. And here we want to host our MongoDB database within a container. So the two are different. The connection strings are different. We're no longer connecting to the local host version of MongoDB. So let's comment that out there. And let's comment that in there. This is where we want to connect to. And that's the containerized version of MongoDB. And MagicStream Movies is our database. You can see within the seed.js file, we're actually connecting to the container and then populating the container with the relevant collections with the relevant data here. Okay, so I think we're ready to run Docker Compose. Let's just double check that all our settings are correct. That looks correct. The data's right. Excellent. MagicStream Movies must be our database name. MagicStream Movies. The correct connection strings in place. So this defines the container based on the Mongo image pulled from DockerHub. And this is just a container that gets run once, that runs this command to seed our database. Excellent. Restart no. So we want it to run once and seed the database and then stop running, basically. And we have the volume defined here, and we're referencing that volume here within the MongoDB code here. So this is a definition for essentially the container called Mongo that's going to house our MongoDB database here. And we've got a health check here, which pings the database. And then, so before we run the seed database functionality, we're running this service health condition here to make sure that the database is up and running before the seeding takes place. Okay, and I think we're in a good position to Docker Compose. Let's just check Docker Desktop that nothing's running. Great, that's all good. Got our images there. And I've actually got this Mongo image here because I've run this prior to recording, and it's pulled the Docker image to the Mongo image to my local machine. So I'm actually going to delete this so you can see what happens when you don't have the image on your local machine. So our Docker Compose code is going to pull that image from DockerHub. Right here, the latest image. And that's how we are able to run an instance of MongoDB within the container. And then this, of course, is just for seeding the data, and it runs that seed.js file that I created specifically for seeding the database. So without further ado, let's do that. So let's go docker compose up and then -d to run it in detached mode. Excellent. You can see all the status here as it seeds the data and pulls the Mongo Docker image to your local machine. So Docker volumes are how Docker stores and shares data outside the container's writable layer. So your data survives container restarts, upgrades, and removal. So obviously when you destroy the Docker container within memory, you don't want the data in your database destroyed with that, because when you resurrect your container, you want that data persisted. You want that data there when the container starts up again. So that's what volumes are for. They allow you to map the volume to a storage location on your host machine, so the data persists. Great, so this has been successful. Let's just double check that and run it in our browsers. Let's run the full stack application in our browsers and make sure that that is working. Okay, seems to be a problem. I may have misnamed something. Okay, we can just look at that error here. Developer tools. Okay. Movies, Axios, fetching data. Okay, fair. There's an error fetching the data. So let's just check. I just want to check whether the server code is picking up the data. So let's go to this endpoint. It is. So the data is actually coming back. There seems to be a problem with the client. Let's go localhost. Great. Okay, excellent. So that's working. There must have been some sort of caching issue. That's why it didn't work the first time we ran it. Okay, so that is working now. And this data is being pulled from the MongoDB database that's now housed within the container, and we're able to persist that data to our local machines through what's known as a volume. A Docker volume is a directory managed by Docker, stored on the host, mounted into one or more containers. From the container's point of view, it looks like a normal directory. This is a volume mount, specifically a bind mount from your host machine into the container. When the container starts, Docker mounts the host directory into the container. And that's how volumes work. So we're now pulling this data from the database run within the Mongo container. And if you look here, if you look here at Docker Desktop, we've got the Mongo container running within our container network. Here, we've got the Mongo container running within our container network, along with our Magic Stream API and Magic Stream web containers. Great, so that's all working. We've now created a new container to house our database functionality, our MongoDB database. Excellent. Right, now, in this part of the course, what we're going to do is separate the development environment from the production environment through creating two separate Docker files for each of our components, the client-side component, React component, and the server-side Go Web API component. So we're going to create two separate Docker files first off, because we want an image for each of these components. We want a container image created for the React code and also and we want two images created for the Go Web API code. We want a development image and we want a production image. So this is how we're going to do that. Okay, so firstly, what we want to do is rename this Docker file in the React client code and the root of this directory, Magic Stream client, and we're going to rename this Docker file. So we're sticking to the naming convention, but we're adding .dev like this. So we're distinguishing this particular code that creates the relevant image for the React code. So we're creating a separate, distinct image for this React client component. And we do that firstly by distinguishing it through naming convention dockerfile.dev like this. Great. And then we're going to create a production version of this image, which is slightly more optimized. I'm not going to go through the lines of code within the production image, but we can do that perhaps a bit later. But for now, I just want to separate the development image from the production image. So how we do that, I'm just going to duplicate this. So I'm going to go Control-C and then Control-V. So I'm just duplicating that just for efficiency, Dockerfile dot, and we're going to call this .prod. So we're separating the production image from the development image. And then I'm just going to paste in the code for the production version of the image from a file that I've got off screen. I'm not going to go through all of the code here, but you can see a clear difference here in that it exposes port 80 and we're using Nginx to host the React code, to host the compiled React code. Excellent. So you can see the code here. I'm not going to go through explaining every line here, as I said before, but we have separated the two images through the different naming conventions here. So we've got dockerfile.prod and we've got dockerfile.dev there. And we want to do the same in the Go, for the Go component, the Web API component. So let's go into the root of this component here, server. And then we've got the Docker file, and we're just going to rename this dev because this is the exact code we want for the dev image. So .dev. Let's duplicate that by just going Control-C, Control-V, and then let's rename the duplicated file, and we want this renamed dockerfile.prod. Excellent. And I'm going to do the same thing. I'm just going to copy the relevant code, which is just a more optimized version of the dev code. And I'm just going to paste it into the dockerfile.prod file here. Excellent. And now we need to build our images. But firstly, I just want to make sure that I'm not running anything. I want to just be on a clean slate here. So you can see we're running all these containers here at the moment. I'm just going to use Docker Desktop to delete these. And you can actually just do it from here. You can delete the whole bunch by just deleting from the top level network node. Okay, and that's cleared it. And then we've got the images here. Just for clarity, I'm actually going to delete these. We could leave them there, but I'd rather just start on a clean slate. So I'm going to delete this one, Magic Stream API, the Magic Stream API image, and then the Magic Stream web image too. Let's delete that. Great, so we're on a clean slate there and we can build our images. And just a note, I'm going to keep the Mongo image. We don't have to rebuild that Mongo image. We'll just keep that on our local machines just for efficiency. And now we want to build those images. So first thing, we want to navigate into the client directory. So let's go cd dot client magic stream client, like that. So we're in the appropriate directory, we're in the root of the client directory, and let's build our image. Okay, so it's just docker build. We've done this before, but here's the little twist, is we've now changed our file names. We're now distinguishing the dev image from the production image. So we need to include the switch or option -f, -f if you like, and then dockerfile.dev. So we are specifying a particular file here. That's why we've got a particular file name here, dockerfile.dev. If we didn't have this -f, it's going to look for Dockerfile without this, but we want to specify the appropriate file, which is dockerfile.dev. So we're trying to separate production from development, a production image from a development image. Okay, and let's go -t. This is the same as before, -t to name our image, and we're going to call this Magic Stream Web -dev, and let's give it a version number. So 1.0.0 like that, and then dot, that's the build context, which is the root of our client code, and let's press the enter key, and that should build our image without a problem. And it's looking good, and it'll build it layer by layer, which is the same as saying line by line from our Docker file. Okay, 5 of 6 layers, and it's done. Okay, that's brilliant. And for good measure, let's just check that that has indeed built our image. And there it is. Perfect. So it's in our images. If we click on the images tab within Docker Desktop, you can see the image has been built. Magic Stream Web Dev 1.0.0 is the version, and that's the image ID. And let's minimize that, and let's do the same now for the server. So let's go there, and let's go cd. Okay, and it's Magic Stream. No, sorry, I think it's server. Server Magic Stream server, like that. Great, we're in the correct directory. And then we run a similar command. So it's docker build, and we're building our image -f. We want to specify a particular file name, so it's not going to build the image based on Dockerfile, but we want it to build the image based on dockerfile.dev. And then let's name our image, and we want to call this one Magic Stream API-dev : 1.0.0. That's the version. And then we mustn't forget the dot, which signifies the build context, which is the root of the server directory, which contains our Go code. Okay, so let's press the enter key. I think that looks good. Yeah, it does. Okay, and it builds it layer by layer for the server side. Excellent, that looks good. And let's just check Docker. Yep, Docker Desktop, I mean. So we've got Magic Stream API Dev 1.0.0. So we've got our 2 images built now. And we now can look at the Docker Compose files. So we need to now separate the Docker Compose functionality into dev and production. I'll show you how we can do that here. And firstly, you can see the names are different. It's pointing at Magic Stream Dev 1.0.0. We don't want that. because we're now pointing at a different image. So what I'm going to do is just copy and paste the relevant code from Docker Compose that I've got off screen here. Okay, let's select all here and paste over this code. So this is our new Docker Compose file here, and this is actually going to serve as like a base image because we want to override certain settings for both dev and production, for the development environment and the production environment. The production environment will be hosting it, the development environment is our local machine. So we want to keep this basic structure here in our Docker Compose file, but we can override certain settings for the development and the production environments. It kind of works similar to inheritance. So what we do is we include the docker-compose.dev file and a docker-compose.prod file, and within those files we include the settings that we want to override within the docker-compose.yaml file. So firstly, let's create our dev Docker Compose file. So I'm just going to duplicate this one for efficiency. Okay, let's rename this docker-compose.dev.yaml, like that. Okay, and I'm just going to do the same thing for expediency. I'm going to copy the relevant code from a file that I've got off screen as a reference, and I'm going to paste it over the code here. Excellent. And you can see this is the dev code that overrides some of the settings in the Docker Compose file here. So you can see I've got all this code commented out in the Docker Compose file, and this signifies a watch mode for when we're running the relevant container in development mode, and we can run, and when we're running both the Go code and the React code in their container, in their respective containers in development mode, we can include this watch option, which means we can actually change the code in real time and see the effects of that in real time. So if we change a heading, for example, of the home page for the React UI, it will immediately show up on the UI within the browser. So this makes for an excellent debugging facility, which is provided by Docker Desktop. So I'll show you how we can do that using the watch option, basically. Okay, but firstly, let's also include the production version of the Docker Compose file. So I'm just going to duplicate the Docker Compose file like this, and I'm going to create the file. I'm going to rename the file Docker Compose like that .prod. Okay, perfect. And then I need to paste the actual production code from a file I've got off screen over the duplicated code here. And there we go. And you can see what's going on here in production. It's actually pulling a production version of the image, and I'll explain this code a little bit later in terms of the versioning, which will become relevant when we create the production version on Hostinger. But you can see we're overriding the ports, for example. We want to run the React code, the web code. We want to run that on port 8081. So we're mapping the Nginx port that we've exposed from our Docker file. Let's just have a quick look at that. Docker file here, dockerfile.dev. You can see we're exposing. The dev is actually exposing 5173, but the production we're actually exposing port 80, the Nginx port there. And then within the production version of the Docker Compose file, we are mapping that port 80 to port 8081, whereas on our dev environment, we're using the default React port, which is, I think, 5173, if I'm not mistaken. Let's just double check. 5173. We're exposing that port and mapping 5173 to 5173 in our dev code here, and you can see that here. So you can see we're overriding some of the settings in the Docker Compose, the base file for our Docker Compose functionality, and we're overriding some of the settings appropriate to the relevant environment. So here's the dev environment, and you can see the name, Magic Stream Web Dev. And one thing I've just caught is that in my reference file, the version is 1.0 1.0.1, and we need that to be 1.0.0, so I'm going to change the name of that to match the image. 1.0.0 there, and the rest of it I'm happy with. The doc, okay. Image name, yep. Server name, Magic Stream API dev. Okay, and we've made sure that the versions are correct. And you can see the container name, Magic Stream API dev. The container name here, Magic Stream Web Dev. And the port mapping is appropriate for the development environment. The context, you can see there, the Docker file, Docker dev. That's appropriate to the development environment. That's the relevant file that contains the image definition. And then here, this is important, we're including a develop section with the watch option here, which means we can run Docker Compose in watch mode, which means we can change code in real time and see those changes propagate in real time while we're actually running the code, which is an excellent feature. So, and you can see actions sync, the relevant paths are included. So if you change, for example, a dependency, that can be propagated through, because you can see we've included the path to client, Magic Stream client package, package.json, for example. So if a new reference is included, if you're adding a new reference while you're coding a change, that change will propagate through to the code you're running in real time. So this is an excellent way for you to be able to debug your full stack application. And the same is true for the Go code. You can also run it in watch mode and make changes that will propagate through while you're running your code in real time. So those are excellent features. And then in production, let's have a quick look at production. Not so concerned with production at this point. We'll look at production when we port to hosting it. But you can see here the relevant differences between production and the base Docker Compose image here. We're still including all the environment variables in the base image. But it's actually a good way to clean up your code is by including these overrides, which are much like how it works in inheritance, where you use inheritance for cleaner code. So you've got dev and you've got prod. They're overriding the appropriate settings. So we're keeping the environment variables in the base image, but I've commented out the watch code, and because that's only relevant to the dev environment. So I'm actually going to delete those settings here. And let's delete the watch settings for the web code, the client React code. Great, that looks good. We're overriding the ports. We can keep that there, but we are overriding them. And note that we're keeping all the DB functionality within the base docker-compose.yaml file, because this applies to both the development and the production environment. But I will say there's a caveat here. In production, you don't really want to seed your data like this, but we're doing this just for demonstration purposes, so the data is populated and we can see what's going on immediately. So that's the reason why we are including the seed functionality here, just for efficiency, for demonstration purposes. But I wouldn't advise you to include such functionality when you are deploying to production. But this does apply in our case here, just for demonstration purposes, to both the dev and production environment, and that's why I'm keeping it in the docker-compose.yaml base file, if you like. Yeah. Okay, so now we want to run Docker Compose. I think we're happy with all of this. Could be wrong. We'll see what happens when we run it. Might all blow up, but hopefully it won't. That is incorrect. We want that 1.0.0, 1.0.0, even though it will be overridden anyway by the Docker Compose dev or Docker Compose prod file. I think we should still make sure that that version is correct in the base file. Great, and let's just look at Docker Desktop. I think we're now ready. We've got Mongo as an image. We don't want that to change. Magic Stream Web Dev, we've created these images, 1.0.0. We're referencing them from our Docker Compose dev file, correct, with their correct names. And now I think we can just run Docker Compose. And you'll see that the way we run Docker Compose is slightly different, because we are, once again, just as we saw with when we were creating specific dev and prod images, we are going to be referencing specific Docker Compose files. So we need the -f, and you'll see how we use that now. Okay, so let's run our Docker Compose file, -f. Let's include the base base Docker Compose file here, .yaml. And let's include the dev Docker Compose file here, docker-compose.dev.yaml, like that. And then we want to run it in watch mode. So instead of running it in up mode, where you'll just be running your code to test your code, we're running it in watch mode. So that means we can make changes to our code, and the code will propagate through in real time. So you could change your server-side code or your client code, and those changes will be propagated through, and this makes for an excellent debugging tool. So I'm including watch here instead of, for example, up within this Docker Compose command. And docker-compose-f, docker-compose-yaml-f, docker-compose.dev.yaml. So some of the dev settings will override the Docker Compose settings, because those settings are specific to our dev environment. Let's press the enter key and see what happens. Okay, and that's looking good so far. It's building our containers. Built, good. Wow. It's pretty fast. Starting. Watch enabled. Okay, it's pretty exciting. So let's go to our browser here. And let's test running our code in watch mode. We've set up our dev environment through our images and our Docker Compose files. Let's see what happens when we run our code. Okay. Wow. Excellent. Look at that. So we're already there. And I'm going to just put this in the right pane like this and put our code in the left pane. And let's make a basic change and see if it propagates through. See if our watch mode is working as expected. So let's go into the code, src components. Let's go to the home component here. Move that across just a touch. Okay, let's go down to where it's rendering out the relevant elements to the browser. And let's include a h2 tag like this. And I'm just going to include a heading, Magic Stream Movies. Whoops. Like that. And when we save it, we want to make sure, we want the Magic Stream heading, the Magic Stream Movies heading, to appear right here when we save it, to test that our watch mode is indeed working. And so I'm going to go Control S. Look at that. In real time, it changed it in the browser, and that's exactly what we want to see. Our watch mode and our development environment is just working magnificently. So if I went Magic Stream Movies, excellent, something like that, whatever. Magic Stream Movies, excellent. And there we go. And if we remove it, real time. So we can now debug our code in real time on our development environments. Excellent. We're going to build the production version of these images now, and we're going to push them to DockerHub, because when we deploy to Hostinger, you can see in our docker-compose.prod.yaml file, we're pulling those images down from DockerHub. So if they don't exist on Hostinger, they will be pulled down from DockerHub first, and then in when we subsequently run Docker Compose, those images will be local, so they'll be run from, the containers will be created from the images that are running locally. So the first thing, if the images are not found locally, they get pulled from DockerHub here. Okay. And the other thing we need to be aware of is that if the image tag doesn't exist here in the environment variable, it's going to tag it with latest. So that's a default tag that it'll give it. But I've configured, so for production, I've made it possible to configure the version here. So this is the appropriate version we want, 1.0.0 for the production images. So let's build those images first, and then we'll push them to DockerHub. So you want to go to DockerHub, it's this here, hub.docker.com, and create yourself a free account. So you got my hub here, you got my repositories. I don't have any repositories in there at the moment. That's why it just says create repository. So if you don't have any repositories, this is the screen you'll see. And you can download the desktop application, Docker Desktop, from here for Windows, Mac, or Linux. Okay. So I've already got that running on my desktop. So I'm going to build these images. And just to be clear, if you look here, my account, my username is Gavin Lon. So that's what you must precede your images with before you push them to DockerHub, like this. So we've got Gavin Lon / and then the name of the image and then the tag, the image tag. And as discussed, that image, if it exists within the .env file in the root of the Magic Stream application, it will pull in this setting here, which is set to 1.0.0, which is the version we want. And then it'll tag it appropriately through this docker-compose.prod.yaml file. And it'll do that for both components. So the production version of the Docker Compose file is a lot more simpler. You don't have all the watch functionality here. It just says restart always. And that's going to come in handy when we create our CI/CD pipeline, our continuous integration, continuous deployment pipeline a little bit later. So when we make a change locally and we push it to GitHub, a GitHub action will run and it will pull all the latest images down to Hostinger and restart the image. So it will be seamless to the users of our application when we make changes. So it'll be seamless when they're running their application. The changes will just propagate through when we make a change locally and push to GitHub. All of those changes propagate through to Hostinger, and we will encapsulate that functionality a little bit later in a GitHub action. But for now, all we want to do is create these images and push them to DockerHub, because our GitHub action will contain code that pulls these images down to Hostinger. You'll see the details of this a little bit later. For now, let's just build the images. Okay, so it's the same as before with a few little twists. So we want docker build -f, and we want to reference the production version of the image. This is for the client. We're in the root of the client component. -t, and we want to name our image Gavin Lon. So it'll be your username for your DockerHub account, /, and then what you want to call your production version web -prod : 1.0.0, like this. And then don't forget the dot for the build context, which is the root for the React component code. And let's just double check Docker file. Oops, nearly made a mistake there. Always beneficial to have a quick second look before you run stuff. Docker build -f dockerfile.prod -t Gavin Lon / Magic Stream Web Prod : 1.0.0. Enter. Great, it's building the image for us. That looks good. And it's pretty quick, pretty efficient. 4 of 6 layers. It's the 4th layer of 6 layers that is currently running. Run npm CI. I can imagine that takes a little bit of time. Okay, great. 5 of 6 layers. It's copying all the source code, and we're running npm build. Excellent, and that's been successful. Great, so we can check that that image has been created locally, because it will create it locally first, and there it is. There's our image for Magic Stream Web Prod 1.0.0, so that image has been created. And we're going to actually push that to DockerHub right now. So let's do that. And the command for that is very simple. It's just docker push. You need to be logged into your DockerHub account. If you are not, it should prompt you to log in. But I'm logged in, so let's see what happens. Docker push, and then Gavin Lon / Magic Stream Web -prod. So Magic Stream Web -prod, production version of the image. Docker push. Okay. : and then the version 1.0.0. And you know what? I think that's it. So it's a pretty simple command. Docker push Gavin Lon / magic stream web prod. Okay, press the enter key. And we should see that within DockerHub once it has pushed that image to DockerHub. But you must make sure you're logged on to DockerHub before this can be done. Excellent digest, and it's given me some sort of unique ID here, which means everything has gone through as expected. So if we go to my hub here, there it is. You're actually looking at your DockerHub repositories through Docker Desktop here, because I'm logged in as Gavin Lon through Docker Desktop. So, and if we go to the actual website, you'll see the same thing. If I refresh this, there it is. Great. So that's successful. Now we want to do the same thing for the Golang code on the server. Let's just clear that. And then let's go to the server. We're on the server here. We can clear. And let's create the image. So it is the same thing, but just for the server-side code. Docker build -f dockerfile.prod. We're specifying a particular file of the production version of the image. -t space, and then it's Gavin Lon, my DockerHub username / magic -stream -API -prod. That looks good. And then we want :1.0.0 like that. So it's Docker build -f specifying the production code for the image we want to build. Dockerfile.prod -t Gavin Lon magic stream API prod :1.0.0. And I think that's good. Let's build it. Error docker build. What? Oh, okay. I've been an idiot. I forgot the dot. I keep reminding you to include the dot and then I forget. Silly of me. Okay. Let's copy. Oh, I'm just going to clear the screen. Okay. So what we forgot is the dot here. Docker build -f dockerfile.prod -t Gavin Lon / magic stream API -prod :1.0.0, and then don't forget the dot. That's the build context, which is the magic stream server root directory for all our server-side code, the Golang web API code. And let's press enter. Now it's working. Okay, don't forget the dot is the moral of that story. Okay, so it's going through the build process. Oh, 1 of 6, so this one's taking a bit more time, a bit more involved on the server side, it seems. But we are getting there. Always need to have patience when we're installing things, when we're building things, and compiling things and rendering things. Okay, 4 of 6, run go mod, download. The 4th layer of 6 layers is running. So the 4th line in our dockerfile.prod file is running. Go mod, and that's to do with the dependencies. It's downloading the dependencies, which of course takes a bit of time. But we're getting there. Great, we're on the 6th layer, run go build. Excellent, API Golang. And we're nearly there. Exciting. Excellent. So that's worked. Let's take a look at our image through DockerHub. Okay, we don't want my hub just yet. We haven't pushed it to DockerHub yet. Let's go to local images, and you can see it there. Magic Stream API prod 1.00, and that's the image ID. And now we can push that to DockerHub. Let's clear the screen, and we can use the docker push command. So it's docker push Gavin Lon / magic stream API prod :1.0.0. And in fact, I think that's it. So it's docker push gavinlon/magicstream API prod 1.0.0, and let's see if that works. And you must be logged into DockerHub for this to work. If you're not, it should prompt you and you can do it while running this process. Okay. Looks like it's doing something positive there. Okay, let's see if it's built our API. So let's just double check. So here's the Golang. Built that image. Okay. Pushing that there. Let's go and check. So, okay, so gavinlon/magicstream API prod, and it's got its image ID there. And that looks good. If we go to my hub, we can see both images there have been pushed. Great. So we're ready to build the production environment to deploy our MagicStream full stack web application running in containers, containerized full stack web application on Hostinger. So in the cloud. It's very exciting. And we're going to create a continuous integration, continuous deployment pipeline. So when we change something locally, we can just check that into GitHub and it propagates straight through to Hostinger seamlessly. So our users barely notice any downtime whatsoever. And that's what we're striving for here. So in this part of the course, we are going to push the code in our MagicStream app project to a repository on GitHub of the same name. The reason we are doing this is because later we want to create a GitHub action to facilitate a CI/CD, continuous integration, continuous deployment pipeline. This means we will be able to make changes to the code in our MagicStream app project within Visual Studio Code on our local machines. And when we push the changes to the relevant GitHub repository, our changes will, like magic, propagate through to the production version, which will be hosted on Hostinger. So when changes are made to the code, the changes are seamlessly propagated through to Hostinger, and the users of our app are not inconvenienced by the relevant live update, and the restarting of the containers will be appropriately handled. But before we push our code to GitHub, we need to make some minor code changes. The reason for this is because when the code was first created, the code that now exists in the MagicStream repository, it was created to use HTTP-only cookies to store authentication tokens, which is great for the prevention of XSS attacks. The use of HTTPS was also a key part of the cybersecurity strategy. In this version of the code, however, I've decided to use HTTP and not HTTPS for the communication between the client React code and the web API code written in Golang. The reason for this choice is so as not to muddy the waters, as it were, with the certificate-related code we would need to include within the relevant GitHub action that we are going to create a little bit later for the facilitation of our CI/CD pipeline. I would, however, encourage you to get the code working later with HTTPS, because this is important in terms of security. But in this video, I want the focus to be on the CI/CD pipeline and how Docker Compose fits into it. The reason we need to change the code in these two methods, the login user method and the logout user method, is because the code used for storing the HTTP-only cookies used for authentication is slightly different in comparison to the code that was originally created for this purpose, where HTTPS is used. If we do not make these appropriate code changes, there will be issues with the login and logout functionality. I encourage you to check out the original course on the freeCodeCamp English YouTube channel, where I take you through a step-by-step demonstration of creating the code for the MagicStream full stack web application. So if you haven't completely understood what I've just explained here, going through this course may provide you with clarity on this. So to get this code originally tailored to work with HTTPS to work for HTTP, we need to make minor code changes to the login user and logout user methods, where we are dealing with HTTP only cookies. For simplicity, you can just copy those methods from the MagicStream deploy repository, where the appropriate code changes have already been made, and then paste them over their counterpart methods in the MagicStream app code that you currently have open in Visual Studio Code on your local machines. Okay, so the first thing we want to do before we push our code for Magic Stream app to a repository of the same name, we'll create the repository in just a bit. We need to make changes to the login user and logout user methods because we are currently handling the storage of our HTTP only cookies with code that is appropriate to HTTPS, and we need to change this code so it's appropriate just to HTTP. If you don't fully understand this, it doesn't matter. This is just something we need to do to make sure that the authentication still works when we deploy to Hostinger. At the moment, this won't work within our containers for authentication. So we need to make these necessary adjustments before we push the code to the relevant repository on GitHub. So to do that, let's just go to our browsers, and I'm going to go to GitHub where I'm currently logged into my account, and the updated code can be found in this repository, Magic Stream deploy. So let's go in there, and if we go to the server-side code, and then we want controllers, and user control contains the login user and logout user methods. Okay, so here it is. That's login user. So, right, so to copy the method, I'm going to just get that method there. Oh, and we've got logout handler below it there for the logout functionality. And it's just called logout handler, login user, and the logout handler function. These are the two we want to copy. So let's just grab those, copy the code to our clipboards. Let's go into our code. Let's go into our code and let's replace these functions here, login user and logout handler here, and just paste that code in over it. And if you'll notice that the storage of the HTTP only cookies are handled slightly differently. So now we've replaced that cookie, the HTTP only cookie handling functionality for the login user method and the logout handler method. Great. So we can now check in our code. So the first thing I want to do is create a new terminal window, but for git bash like this. Okay. Right. Perfect. So we're going to use git bash to run our commands in the terminal. And you can see that we're in the appropriate directory here, Magic Stream app. So firstly, I want to create a repository, and you can log in with your GitHub credentials and also create a repository of the same name if you're following along. So I'm going to create a repository here like this, new repository, and I'm going to call this Magic Stream app like that. So we want to call it Magic Stream app like that there. And then just create repository. So we're creating an empty repository, and we're going to use commands to push our code to this repository. Okay, excellent. So let's go back here. And then the commands are pretty simple. We go git init to initialize our repository locally. So it's initialized empty repository. And then we want to go git add dot to add our code to that repository locally. Okay, just going to clear the screen. So we've done git add dot, and then git, we want to commit our code, git commit like this, -m, and then we want to include a message. I'm just going to say initial commit. So just a very basic message like that. Okay, initial commit, git commit, yep. Let's press the enter key. Okay, it's committed the code locally. Well, firstly, we want to make sure that we're in the main branch. So I'm going to go git branch -m, capital M, and then main, like this. Enter. And now we need to push the code to the repository, the remote repository hosted on GitHub. So that command is git remote, like that, add origin, like this. And then we need to include, so in fact, here is the code we want, right here. That's the code we need in order to push it. We've done the branch main, and we need to run this command here. So I'm just going to copy that from sample code created for us after we created the Magic Stream app repository on GitHub. So we've already got much of the code already written, but I'm going to delete that and just paste that there. And that is actually the code we want, that we've created from the sample code created when we created the relevant Magic Stream app GitHub repository. And let's press the enter key. Okay, it's done that for us. Okay, and now we can just run git push -u origin, and main is the branch. So git push -u origin main, like that. Press the enter key. Great, and that looks positive. Wow, that was actually pretty quick. And let's see that if our code has been appropriately pushed to our Magic Stream app repository. And there it is. That's excellent. So we're now ready for the next stage, which is basically getting a working version up on Hostinger. And then we'll write the GitHub action to automate the CI/CD pipeline. So we're in good shape here. Brilliant. Okay, so we've just made a modification to our code, and therefore we want to build our images again. We're going to alter the version here. For example, for the docker-compose.dev.yaml file, we're going to alter this to version 1.0.1 because we've created a new version of the code, and I want to make sure that everything is worked so that the modifications we've just made will not affect the functionality of our code, the functioning of our code in a negative way. So we need to test that. We've changed the way we're handling HTTP only cookies so that we're using HTTP rather than HTTPS. And I just want to make sure that the modification we made to the login functionality and logout functionality hasn't affected the overall functionality, the functioning of our application. So because of that modification, we're now increasing our versioning. And this is obviously a subjective thing, how, up to change management, how this would be done regarding a particular application. But I've just decided for demo purposes, what we're going to do here is increase the version number for the docker-compose.dev YAML file, and then we'll do it also for the production version of Docker Compose. So for the API component, we want 1.0.1 here. And then also for the client React component, for the image for the React container, we also want 1.0.1. So our containers now have, so we've incremented the version for our containers here, basically in Docker Compose Dev. And we want to do the same thing in production, docker-compose.prod.yaml. And you can see here, this is handled differently. It's handled through configuration. So it's picking up an image tag environment variable here and then injecting that value into the actual code when we run Docker Compose. And that value can be found in .env, which needs to be on the local machine. So we've got image underscore tag, and we want to just update that to 1.0.1 like that. And let's save that. And you can see that the modifications are, okay, the .env file doesn't go into GitHub, so it doesn't check it out or anything because it doesn't exist in GitHub, because we've got a git ignore file that makes sure that the .env files is not checked into GitHub. But this has automatically checked out docker-compose.dev.yaml, this modification here. So we're going to want to check this modification into GitHub. So everything's consistent with our local environment versus our production environment in terms of code. Even though this Docker Compose file will not be run on hosting it, we're going to run the production version for obvious reasons. This is to do with the production environment. The .prod.yaml, the docker-compose.prod.yaml file is to do with the production environment, and the docker-compose.dev.yaml file is to do with the establishing the dev environment. So firstly, let's just test our changes to make sure that it hasn't affected the functionality of our full stack web application. So let's go to Docker desktop here, and let's just down, as it were, these containers, just so that we're starting from a clean slate. So I'm just going to hit the delete for the main node that encapsulates the other containers. So represents the network of containers, and we're just deleting it. Delete forever, and it downs all of its constituent containers, if you like, within the network of containers. And these images can stay as they are because you can see their versions are 1.0.0, 1.0.0. They're all 1.0.0, and we're just creating another version of these images. So we're going to rebuild those images for 1.0.1 instead of 1.0.0. So let's rebuild our images. Okay, so I'm going to go into cd client, magic stream dash client, like that. Okay, so we're in the root directory of the client code, the React code, and we want to build our image. So we go docker build dash F, and we want to build this image based on the development version of the Docker file. So that's why we've got the -F switch there. So it's -F and then docker file dev, like this, -T because we want to name our image and we're going to include the new version of this particular image. So -T and then magic -stream -web -dev. That's our naming convention, colon, and then the version 1.0.1. Okay, and then don't forget the dot, which indicates our build context, which is of course the root directory for the React component. And let's press the enter key. Great, and it will build our image for us. Excellent, and we can verify that our image has been built through Docker Desktop, and we've got the images there. And you can see now we've got a Magic Stream Web Dev image created, but the difference between the previously created image is this one has a version of 1.0.1 and the previous version is 1.0.0. So we've got our new image there, and we want to do the same for the server. I'm just going to clear the screen. Oops, clear the screen, and let's go back to the root. And let's go cd server magic stream server. So we're in the root directory of the server code, which is written in Golang for our web API component. And we do a similar thing, but for our web API code. So we're building an image now for our web API code. So let's go docker build. Oops. Docker build -F docker file.dev and then -T and then magic dash the name of the image, magic dash stream dash API dash dev. Okay, and then colon 1.0.1, like that. And then of course don't forget the build context signified by this dot. And let's press the enter key and build our new image. No such file. Oh, it's because of the capital letter, I think. Case sensitive. Yeah, okay. So it's obviously case sensitive, that command. So that's the reason why that failed. So I'm just going to copy that there to my clipboard, paste it in there, and then change this to a small f. So a bit of an oopsie there. Okay, so build that around, that should work. Press the enter key and off it goes. Great. Okay. And it's done. So let's go to Docker Desktop, double check, and there it is. So we've got our Magic Stream Web Dev and Magic Stream API Dev version 1.0.1. Great, okay, let's clear that. And now let's check that into, we actually only made one subsequent modification, docker-compose.dev, YAML. Let's check that into GitHub so that everything is consistent. Okay, and this environment variable, of course, doesn't go into GitHub, and we would have to change that on Hostinger. We have to manually create the .env file, but you'll see that in just a bit. And you'll see what we do there in just a bit. But for now, let's go to Git Bash. So I'm going to create a new terminal for Git Bash, and we're going to check that code modification in. Okay. And it's simply git add dot. Great. Git commit dash m. I'm just going to go minor modification to image to docker-compose.dev file regarding versioning. Okay, not a very good message, but anyway. Okay, so that'll do. Git commit minor modification to docker-compose.dev file regarding versioning. Okay, great. So press the enter key. Okay, it's made that minor change for us. And then we're in the main directory there, the main branch, and it's just git push to push that change to our remote repository on GitHub. Press the enter key. Excellent. That should have propagated through to our GitHub repository appropriately. Okay, I'm going to clear that there. Let's go back to our other terminal window for PowerShell. And now I want to, let's go to the root, because I want to run Docker Compose for our development environment and just make sure that our code is okay since we made these changes. So let's type Docker Compose, and then it's a switch F because we want the dev version of Docker Compose. docker-compose.dev.yaml, like that. In fact, I've got that wrong. It's docker-compose.yaml. And then we want to run the development version of Docker Compose over the base Docker Compose file. So it's docker-compose.dev.yaml, like that. And then up, and let's run it in detached mode -d, like that. So docker-compose-f, docker-compose-yaml-f, docker-compose.dev.yaml, and I think that should do it. Let's see what happens. Okay, it's building everything as expected. Okay, excellent. Let's just make sure that those containers are now up and going. Go to containers, and they are. Okay, and you can see they were built, what image they were built from, 1.0.1. That's excellent. Now we can test our code through our browsers. Let's go to localhost :5173 and make sure. Great. Everything looks great there. That's all working. Log in. bobjones@hotmail.com. Password 1! With the P capitalized. Log in. And we're good. We've logged in as Bob, and we can see his recommendations, and we can run a movie if we want. Brilliant. Everything's working correctly. Okay. Okay, so now what we're going to do is we're going to create an installation on Hostinger. So this is the production version of our full stack web application. And the way we're going to do it is we're going to do a one-time installation first before we write a GitHub action that will automate the process. Whenever we push changes to GitHub, it will automatically, like magic, be propagated through to Hostinger and just work. So first off, though, we need to rebuild the images and push them to DockerHub. These are the production images. So let's do that. So I'm going to go into, let's go into the client first. Magic stream client. Okay, clear the screen. And we're going to create the production version of the image for the client. Docker build, okay, -f, and then dockerfile.prod, because we want to use the production version of Dockerfile to build our image in this particular case, and then -t, and we must remember to use your account username for DockerHub to precede the image name. And that's important. That's an important convention for when you're going to push a Docker image to DockerHub. Okay, so I've included my username preceding the name for the image, which is magic stream web prod in this particular case, and then colon 1.0.1. Excellent. And don't forget to include the dot for the build context. So docker build -f dockerfile.prod -t gavinlon /magicstreamwebprod1. That's exactly what I want. Press enter. And it's building the production version of the image, which contains our changes, getting the HTTP cookies to play nicely on HTTP, the HTTP only cookies, which is the code change we made to the logout and login functionality earlier on. And that we're basically rebuilding the images to reflect that change. Okay, and then let's clear the screen. Okay, and we want to just check that that has built the image. Go to images. There it is. There it is, 1.0.1. So we built that there. And in fact, we want to push that now to DockerHub. So I'm just going to go to DockerHub. Okay, so I'm signed into DockerHub. You can see we've already got these. So if we go into that repository, you can see we've got 1.0.0 in that repository, Magic Stream API prod. And the same is true for the client-side React code. We go in there, you can see we've got our tags, be 1.0.0, and we want 1.0.1 now included there. So we're going to be uploading this new version to these repositories here. Okay, great. So now we want to push that to DockerHub. We've made sure that we are logged in to DockerHub before we do this. So docker push and then gavinlon. That's my DockerHub username. So you would want your DockerHub username followed by / and then the name magic stream -web -dev. No, sorry, whoops. Prod. This is for the production environment. And then colon 1.0.1. Excellent. And that is our command. And let's press the enter key. Push refers to repository, right? Excellent. Okay. And it should have done that. That looks good. And let's in fact go to see if that has worked. So if we go to this repository, has it now uploaded that? And it has. 1.0.1. So that image has now been uploaded successfully. The new version of the image has been uploaded to the relevant repository on DockerHub. And we need to do the same for the server. So let's do that. Let's clear the screen here I'm going to go cd, go to the root and cd server / magic stream server, and we want to build an image, a production image for the server. So let's do that. So it's docker build -f, then docker file.prod, okay, -t Gavin Lon, so the username, your username for DockerHub / magic stream API -prod : 1.0.1 for the build context. Great, let's build that. That should be reflected locally first. Excellent. Looking good. Excellent. So let's double check that that has indeed created the image. And so we've got 1.01 image for the web. And there it is. Gavin Lon Magic Stream API prod 1.0.1. So we've got the previous version there. And this is the latest version, the current version 1.0.1. Excellent. We can now push that. Let's clear the screen first and let's push that to DockerHub. Push. Docker push. Okay. And then we want Gavin Lon, the user account for DockerHub, followed by the name / then magic stream API prod : 1.0.1. Excellent. Let's push that to DockerHub. Excellent. Awesome. Perfect. That looks great. Let's go to Docker Desktop and verify. Well, I actually want to go to DockerHub, but we can verify it through Docker Desktop actually. So if we go to My Hub, you should be able to see them there. And there you go. 1.1 for the API, 1.1 for the client side. So we've got 2 images pushed. 2 images for the server-side code and 2 images for the client-side code. Pushed to DockerHub, and you can see this is the latest version 1.0.1 that we've just created due to a code change. We want to distinguish it from the previous image, and we have done through versioning through the tags. And you can see here now, if we go to on the DockerHub website, if we go to this repository, Magic Stream API prod, you can see now we've got the new version pushed to DockerHub. You can look at all the tags we've got. We've got 1.0.0 version and 1.0.1. Excellent. Right, so now before we create our GitHub action to automate the process of when we make changes to our code and we push our code to GitHub, it automatically gets, those changes automatically get propagated to Hostinger. We want to do a one-off setup. So we're going to go into Hostinger and we're going to manually pull the code down from GitHub to Hostinger. We're going to create an environment, a .env file on Hostinger in a designated directory. And then we're going to run docker-compose to check that everything is good. And then after we've done that, we will create the Git action to automate our CI/CD pipeline. So let's log on to Hostinger. Okay, so www.hostinger.com. Let's go to Hostinger, go to my account. I'm going to log in. So I'm logging into Hostinger. So I'm assuming you've got if you're following along, you've got an account set up already where you can use Docker on a VPS, virtual private server. Okay, great. And then the first thing I want to do is hit manage. I want to manage my virtual private server. So I'm going to hit manage there. Okay, I'm just going to skip that. Great. You can see and I'm running Ubuntu 24.04. Great, and I'm actually running N8N also, built on Ubuntu 24.04. Excellent, and you can see now we've got this Docker Manager option here, and you can see whatever projects you've got running by hitting this option here. Great. So I'm running 2 containers. That would be my N8N related functionality within a container. But I want to now spin up the relevant containers for our Magic Stream app, full stack web application. So how I'm going to do that? Firstly, I'm going to go to terminal, because we can run commands for Docker from within our own terminal here. So hit terminal, and we can run the relevant commands we need to run on our VPS. Excellent. So you can see I'm on my server there. I'm in the root directory, and I'm just going to clear the screen for clarity. And the first thing I'm going to do, now that I'm on my server, my VPS on Hostinger, is I'm going to create a new directory, and I'm going to use mkdir, the mkdir command for that, followed by the name of the directory I want to create, Magic Stream App, like that. And I'm going to cd into that now, Magic Stream App. So I'm in the directory of where I want my project to reside, all the relevant files. Okay, so the first thing I'm going to do is I'm going to clone the GitHub repository into this directory. So to do that, we run this command, git clone https:// then github.com, and then my GitHub account, username, Gavin Lon Digital. So this will be whatever account name you have, followed by the name of the relevant repository, and that is, in my case, Magic Stream App .git, like that, and then space dot. So git clone https github.com Gavin Lon Digital Magic Stream App.git, and let's see if that clones the repository into our Magic Stream app directory. Cloning, excellent, that's great. And the next thing I want to do is create the relevant .env file. Now this contains the settings that will be injected into our production version of the Docker Compose file when we run Docker Compose to spin up our containers on Hostinger. Okay, so we're in Magic Stream app. We want to create that file. And how we do that, remember we're on Ubuntu, we're on Linux Ubuntu. So we want to use the nano command for this. So it's nano.env. And now we want to paste our settings, our environment variable values. So I've actually got these settings off screen, and I'm just going to paste them in here like that. And there's some adjustments we need to make because we've got all these references to localhost. We're now on Hostinger. So we want these localhost, for example, to reflect our virtual private server name here. So I'm going to make those adjustments, and whatever your virtual private server name is, that is what you'll be replacing localhost with, your virtual private server name. So if I go here, okay, and my virtual private server name is this here, so I'm going to copy that there, and I'm going to paste that in here. Okay. And then the port that I want to run the client on, the React client on, is 88. Oops. I'm going to delete that. The port I want to run this client component on is port 8081, like that. And we also want to replace localhost here, API host, because when the client connects to the server, it must be the correct server name. So we need to paste the correct Hostinger VPS name here. Okay, so that looks good. And this should work. So this is for cause, so that because the client and server are running on two separate domains, we need to allow the client to connect to the server. So that gets around CORS. Okay. Great. That looks good. So next step is to write that out. So we go Control O, write it out, press the Enter key, and then Control X to exit. And we can double check that our settings are there by going nano.env, and you could modify the settings like this also. Nano.env, and it takes us to our settings, which have persisted now. So we've got our settings are correct. So let's go Control X, and now we can run Docker Compose to spin up our containers. Because now our Docker Compose files, because we cloned the repository, our Docker Compose files are now on our VPS within the Magic Stream app folder. So we can run Docker Compose -f, then docker-compose, the base compose file.yaml, and then on top of that we want to run the production version of the Docker Compose, the relevant Docker Compose file, and that file is named docker-compose.prod.yaml, and let's include the up keyword followed by -d because we want to run the containers in detached mode. So let's test that. Pulling, it's doing its thing. It's looking good. Pretty fast too. Look at that. Okay. And hopefully after this, we've got a version of our web application installed on Hostinger. Pretty exciting. And then we can start to automate our CI/CD pipeline. Wow, look at that. Healthy, created, started. That is looking very positive. And now we can test whether that has worked by typing in the name of our VPS server and :8081, because that's where the React client is running. Press the Enter key. Not secured, that's correct. It's worked first time. We've now deployed our Magic Stream app, full stack web application to Hostinger. And the next step is to develop our CI/CD pipeline so that when we make our changes on our local machines to the code and we push those changes to GitHub, it automatically is reflected within the application running live on Hostinger. That's pretty awesome. Okay, let's just see if we can log in. Okay, Bob Jones at hotmail.com, password 1, exclamation point with the P capitalized. Look at that. How awesome is that? And that is running brilliantly. And let's run the hangover just for good measure to see if our application is streaming movies. And it is. Look at that.
Talking about, well, Phil and Stu, they're your butt.
Okay, excellent. Let's log out. So now we're going to create the GitHub action that is the core part of our CI/CD pipeline automation. And as I've stated earlier, what this means is that when we check in our code with our code changes, this will automatically be reflected live on Hostinger. So it's kind of like magic. Really excited to get to this stage of our course. So the first thing we want to do to create our GitHub action is obey a certain directory structure convention. So we need to create a folder right within the root of the Magic Stream app, and we can just do that by clicking this icon here for new folder. And then this folder must be called GitHub.GitHub. So it's dot preceding GitHub like this. Okay. So we've created that folder, and then within the .github folder, we need to create a subdirectory called workflows. So I've actually already prepared the GitHub action offline. You can actually find the relevant GitHub action if we go to GitHub. So if we look here, we've got Magic Stream deploy. And you can find all of the relevant files here, including the docker-compose.dev, docker-compose.prod.yaml files, docker-compose.yaml file, as well as the dockerfile.dev and dockerfile.prod for the client and the server. And then also we've got this deploy.yaml file, .yml, deploy.yaml, and we're going to create that file on our local machines now within the same directory structure as seen here, because by convention, GitHub knows where to find the relevant actions and will run them based on the events that you detail within your GitHub action. So you can see here is the GitHub action that we want to create, and I'm just going to paste that in to a new file that I'm going to create here within the workflows directory. So I'm going to hit new file and create a file called deploy.yaml like this, or YML. You can call it YAML if you want, but I'm going to just go YML, which is the abbreviated file extension for YAML. And then I'm going to paste the relevant code in here. And let's go over a brief explanation. Incidentally, a useful extension that you might want to install is GitHub Actions here. GitHub Actions extension lets you manage your workflows, view the workflow, run history, and helps with authoring workflows. So it might be useful to install this GitHub Actions extension. Let's go back here and let's go through a brief explanation of what's going on in this YAML file. So we've got the workflow name here, build, push, and deploy to hosting a VPS. That's the name we've chosen for our GitHub action. And here we have on push branches. Runs the workflow every time code is pushed to the main branch. This is what we're declaring here. This is declarative code. And then we've got the jobs section here, okay, which defines a single job called build and deploy. So it's defining a single job called build and deploy. So it runs the job on the latest Ubuntu GitHub hosted runner. Okay, let's go to the steps. This is a list of actions, commands executed sequentially here. And you can see we're checking out the code. So it's going to clone the repository into the runner, which is it's running on the latest version of Ubuntu. Okay, so with fetch depth 0, fetches the entire Git history needed for tags, versioning, or full diffs. And then we've got show API context files here, lists the files in the API Docker build context. True prevents the workflow from failing if the directory doesn't exist. So this true prevents that from occurring. And this is just for debug purposes here. This is how GitHub Actions know how to read settings from secrets. And we're going to create these secrets after we've gone through a brief explanation of this GitHub action. So we're going to create all these settings within secrets. And I'll show you how to do that in just a bit. So we've got the DockerHub username and the DockerHub token. This is how our GitHub action from GitHub is able to log into DockerHub. What it's going to do is it's going to build the images for the client and the server, and it's going to push those to DockerHub, and then it's going to pull those images down to Hostinger, and it's going to up those containers, the relevant containers. So it seamlessly launches the web application in their relevant containers without causing much disturbance to the user. Then we've got build and push API image. So it builds the image on the runner and pushes that to DockerHub, and that image will be retrieved later on to Hostinger, and it will run the relevant container. And then we've got build and push web image. So it does the same thing. It builds the image on the runner, and then it pushes that image to DockerHub, which will later be pulled down on Hostinger, pulled down to Hostinger, and the container will be launched. And then we've got this very important section here, set up SSH agent. So it starts a SSH agent on the runner. That's what this does here. Loads your VPS private key from secrets. So the private key that we're going to generate, and I'll show you how to do that when we set our secrets, which we are going to do straight after this. So it retrieves this from secrets on GitHub, and this is the private key. This allows our GitHub action to run commands on Hostinger. For example, pulling the images down from DockerHub and running the relevant containers. And then deploy on Hostinger VPS. So this add VPS known hosts runs a multi-line shell command. So SSH, hosting a user, hosting a host, connects to the VPS, virtual private server, over SSH. This export image tag here sets the Docker image tag to deploy. So it sets the Docker image tag to deploy. This CD, secrets.host app directory, moves to the app directory on Hostinger. So it makes whatever we've configured here the current directory. So this is from where we will run our next step, our next command, git pull origin main here. So this git pull origin main pulls the latest code, for example, the compose files that we're going to run subsequently. So it's pulling this from git pull origin main. So it's pulling this from GitHub. We're then able to run Docker Compose using the latest compose files on Hostinger. And that's basically what we're doing. So it's an automation. So we're automating our changes. So when we push code to the main branch, so changes that we've made on our local machines, we push that to the main branch. It triggers these actions to occur. So checkout repository, for example, build and push API images, build and push web image, add VPS to known hosts, and then deploy on Hostinger VPS, which starts the containers. But you can see all of this code on GitHub right here in this repository, Magic Stream deploy. Okay, great. Okay, so I just wanted to draw your attention to these commands here. So docker compose /f compose, then compose prod YAML pull. This one here, this command here, pulls the new Docker images from DockerHub. And then this command here recreates containers in detached mode and removes the old ones. And this is how we can have a seamless integration CI/CD pipeline where the changes are made and the changes are propagated through to Hostinger seamlessly for the user. So it removes the old containers and launches the new containers. So this line pulls down the Docker images from DockerHub, and then this line recreates the containers in detached mode and removes the old ones. Remove orphans. Great. So to summarize, in one push to main, this workflow builds API and web Docker images, tags and pushes them to DockerHub, uses SSH to go into your Hostinger VPS, pulls new images, restarts the app using Docker Compose, and it removes the old containers. So now, as you can see, we've got all these secrets. For example, hosting a user, secrets.hosting a host, secrets.hosting a app directory, which is magic-stream-app. We created that app directory in the previous part of the course. Hosting a SSH key, we're going to have to generate SSH keys. I'll show you how we can do that in just a bit. So we've got a lot to do here. We need the DockerHub username, DockerHub token, which we need to create on DockerHub. And this is how we're able to log into DockerHub from our GitHub action. So we need to create those secrets at this point. So I'm going to go into GitHub here and let's go to our current application, which is Magic Stream app. So this is the version of the Magic Stream application that we're working on now. And now we're going to look at how we can create those secrets. So to do that, we want to go into settings. We want to go to secrets and variables here. We want to go to actions. Brilliant. Okay. And we want to create these as new repository secrets. So new repository secret. Now we want to log into DockerHub because we need to generate a DockerHub token. A token so that our GitHub action can log on to DockerHub. Okay, so let's go into DockerHub. Okay, we're signed into DockerHub. So now we want to go to account settings here. We want to go to personal access tokens here. Okay. And you can see I've generated loads of these keys here, and then we just go generate new token. Okay, token description. I'm just going to call this my hosting a token, whatever, call it. I'm just going to put a 30-day expiry date on it. This is very important. Access permissions must be read and write at least. I'm just going to give it read, write, and delete. Okay, so my hosting a token, and let's generate that. Okay, great. So also my username is Gavin Lon, so I'm going to copy that there and just put it temporarily there in Notepad and copy that. This is the actual personal access token that we need to create as a secret in GitHub. Within the relevant GitHub repo, you've now gone to secrets and variables actions, and we want to create a new repository secret. So go new repository secret like this. And then here we want to call this one Docker underscore hub, not underscore, sorry, Docker hub underscore token like that. And then we want to paste in the token that we've just created on DockerHub. So this will allow our GitHub action to log in to DockerHub. Let's paste that there, add secret, and there it is. So if we look at our code here that we haven't yet checked in, but we will do that. We've got DockerHub token now, and it can read that secret now from the secrets that we are creating within the relevant repository here. So it's this repository secrets. We've created DockerHub underscore token, and now let's create DockerHub username. So new repository secret. Let's go DockerHub underscore username like that. And our username, well, my username for DockerHub is Gavin Lon. Yours will of course be different. So paste in what your username is over here and then go add secret like that. Great. So we've added 2 secrets that can now be read from our GitHub action here. So we can read the, so our GitHub action can read our DockerHub username and DockerHub token, which means our GitHub action can now log in to DockerHub and gather relevant information. Okay, so it can pull the images and push images and find certain versioning information, that kind of thing from our GitHub action. Because we're basically giving our GitHub action permission by doing this. And of course, these are secrets here. So no one can come in and just read these secrets. Even if you go to edit, you can't read those secrets. You can update them, but people cannot read them. Okay. So it's fully secure. Okay, and then we can do hosting a app dir also. So new repository secret. Let's go hosting a underscore app underscore dir like this, and it's magic stream app because that's what we called it when we did that one-off setup of our web application on Hostinger. So we want the GitHub action to basically log in via SSH to Hostinger, and then we want it to move to Magic Stream app, that directory, before running the relevant commands, Docker Compose commands. And let's add that secret there. That looks good. Great. So Hostinger app dir. So we've done now 3 of our 6 secrets that we need to create. Okay. And we also need the Hostinger username. Okay, so my Hostinger username, let's create the Hostinger username. Okay, so this Hostinger underscore user setting must be set to root. Excellent. Let's add the secret. And the other hosting setting that we need to include is the IP address of your VPS, your virtual private server, your VPS. Okay, I'm just going to copy my IP address from here. You can see it right on the front page here. So I'm going to copy that there and I'm going to paste it in here. Let's call this hostinger host, like that. And then just paste in whatever the IP addresses of your VPS on hostinger. So here it is here, and you can just copy that there like that, and then paste it in here like that, and then hit add secret. Great, so we've got 5 of our secrets created, and we actually only need to do one more, which is the private SSH key. And we're going to use SSH keygen to generate a private public key pair, and the private key will be stored within a secret on GitHub, and the public key part of the key pair will be installed on hosting, and I'll show you how to do that in just a bit. And that's how our GitHub action can SSH into hostinger and run the relevant commands so that we can propagate the changes through to hostinger. The changes made locally, then they push to GitHub, and then our action runs, and then the relevant images are created, pushed to DockerHub, and then from hostinger, our commands can pull, our Docker Compose commands can pull those images from DockerHub and can run the relevant containers and remove the old containers. So that's how we are able to magically deploy our changes to hostinger. Okay, so now we need to generate a private public key pair, and we're going to do that using a utility called SSH keygen, which is installed on Windows 10, 11, Mac OS, and most Linux distributions. So we're going to run the command line, and we're going to generate a public key pair. And the public key will be stored on hostinger. We'll install that on hosting, and the private key will be set as a secret in our GitHub repository. Going to navigate to C drive, CLS, and I'm going to create mkdir. I'm just going to create a directory called my keys, I don't know, hostinger, whatever. Okay, so I've created that. I'm going to cd into that. My keys, hostinger, right. And now I'm going to run that command. And this is how the command goes. SSH keygen. Okay, so SSH-keygen space -t ed25519 capital C, and then you can call this whatever you want. I'm just going to call it GitHub Actions Hostinger, GitHub Actions Hostinger 4 space, and then the file, we want the file to be hostinger GitHub Actions 4, so whatever you want the file name to be, whatever you want to name the files that will store the relevant key pairs, and you'll see the details of this in just a bit. So SSH keygen -t ed25519 -c GitHub Actions Hostinger 4, and then just -f, and these settings can be pretty much what you like, and that'll be the file name that stores the relevant keys. You'll see what I mean now. So I'm going to press the enter key. So here, enter passphrase, just press enter. Enter same passphrase, just press enter. Leave it empty and press enter. And it's done it for us there. And now we can go out of here and we can go into that directory that we created. So C, I'm just going to go to C drive and then my keys hosting, and we've got these two files now generated for us, and we want to, this will contain the private key, so I'm going to open that up in Notepad. Hit it with Notepad, and now we want to just take this entire key and paste it. So let's create a new repository secret, and I'm going to call this one, we must call this one hostinger, because this is what the secret, this is how the secret is referenced. This is the name of the secret that is referenced in the relevant GitHub action. So it must be hostinger SSH key, like that, with underscores between hostinger and SSH and key, like that. So hostinger SSH key, and then we need to copy all of this, including begin, open SSH private key, and the end part here, and we just paste it in like that, and we add secret. Okay, and now we've got all of the secrets. Now we've created values for all of the secrets here. So the final step now is to go into terminal. Right, skip that. So we go into the terminal here, terminal window. I want to open that. I'm just going to clear the screen. We need to create a particular directory, and this may or may not be created on your VPS. So just to check that it is created or it isn't created, you can type ls-d, and then the directory, the special directory is tilde /dot .ssh, like that. Okay, and that means that I've got that installed. And if you don't have it installed, you're in the root directory here. Sorry, I think that should have been ld, but it did work anyway. Okay, let's just try the ls. So it should be ld, and then tilde dot ssh. Oh, okay, right, so that still worked. It told me that that does exist. Okay, but if it tells you that it doesn't exist, if that directory doesn't exist, you can create it simply by typing mkdir -p and then tilde /dot ssh, ssh, and I don't need to create it because I've already got that directory on my machine, so I'm going to cd into it here. cd tilde /dot ssh here, and then we want to paste that public key into a file called authorized_keys. So we're going to type nano authorized _keys, like that. And if that file exists, it will launch the relevant file. If it doesn't exist, it's going to create it. Well, you will have to save it after modification to create it. But if it already exists, it will open that file in a text editor for us. So nano authorized _keys. And there it is. You can see I've actually already pasted in keys here, public keys for when I was preparing for the course. So all I'm going to do here is hit the enter key. So I'm putting it on a new line, and I'm going to open up that key that we generated, .pub. This is the public key we want. We want to open that up in Notepad. Okay, and we're just going to copy this guy here. Okay, so I'm just going to copy this key here into here. Great. Hosting it for GitHub Actions, hosting it for. And then I'm going to write that out by going Control O, and then press Enter, and then Control X. Great. Okay, and I think we're pretty much there. One thing we have to do though, I'm just going to go to the root here, cd ... like that. Okay, so we're in the root, and we need to secure the directory. So chmod 700. Okay, So this just means that only you have read-write access to it. And this is important or else SSH might not work. So you do have to secure this folder like this. And then chmod 600. Whoops. And we have to do the same for the actual file. The file where we pasted that public key into. We also have to secure it appropriately like this. So auth, and these are just standard Linux security commands, underscore keys like that. So authorized keys. So chmod 600, the relevant path, and the file is authorized keys. Press the enter key. Great. So that should now be secure, and we should actually be ready to test our GitHub action, and we can do that simply by checking a change in from our local machines. So should we give that a try? I think we should. Okay, I just want to make a point quickly that if you go into your .env file, so nano.env, press the enter key. Okay, you can see I've removed the image tag setting. So if you see, for example, image tag equals, and then a version number, 1.0.1, please remove it because we want the latest image to be pulled from DockerHub. So you can see in these repositories, for example, the Magic Stream Web -prod repository, we've got these tags indicating the versions 1.0.0, 1.0.1. We actually want the latest image pulled. So when the GitHub action runs, we want the latest image pulled. So we need to make sure that that image tag setting is removed from the .env file. And you can see the reason for this if we look at the docker-compose.yaml file. You'll see that it's looking for that image tag setting, and if it doesn't exist, it defaults to latest. And the GitHub action is going to create an image with the latest tag, a tag with the literal text latest, and we want those images pulled down for the client and the server for their associated containers. We want the images with the latest tag pulled down to Hostinger before the containers are run. Okay, so I've actually run a few workflows from my GitHub action, and some of them didn't work. You see these initial ones didn't work, and that's because I had some of the settings slightly incorrect. But if you follow the instructions I've given you, those are in fact correct. I just made some minor mistakes and eventually got to the bottom of it. So don't be too hard on yourself if you don't get it right the first time. It is very fiddly and it's very easy to make little mistakes. And that's the problem with this. If you make any tiny little mistake, it won't work. So it's a bit of trial and error here. And eventually I've got it working here. So basically all I did was I tested a minor change to the heading on the home page, and that worked. And then I initialized the heading here, so there's no heading. And I just want to demonstrate that the GitHub action is actually working now, and that when we make changes to our local environment, we can propagate those changes through to Hostinger now through our GitHub action. So pushes the code to GitHub, builds the images on the actual runner here through the GitHub action, builds the Docker images and pushes those images to DockerHub, and then we're able to pull those images down from Hostinger. We've put in the relevant security plumbing, as it were, so it can pull down those images and run them as containers in Hostinger, and also down the old containers. So the new code propagates through to Hostinger. And we're just going to prove that now quickly. Let's go to the code here and let's add a heading. I'm just going to add a quick H2 heading here. H2, and let's just go magic stream heading here. Great, let's save that. And then we can, I'm just going to use git bash here to push that code change through and run our GitHub action. It'll trigger our GitHub action, which will basically deploy our change to hosting, and we should see it in real time when we refresh our browser. Okay, so let's do that. So git add dot, great, then git commit, and I'm just going to give this a very basic message of very basic change to heading in home component. So a bit of a long message there, but it'll certainly stand out when we run our action. You'll see here when we run the workflow, you'll see it over here. You'll see what I mean now. So great, so we commit that change locally, and then let's push it to our repository. So it's git push, we're in the main branch, which is where we want to be, and let's hit the enter key. Great, and that should have kicked off our workflow. Let's check if it has. Let's refresh the actions window here, if you like. And there it is, very basic change to, okay, hedging in home components. So a bit of a typo there, it doesn't matter. It looks like it's working, and hopefully that's going to turn green with a tick, and that means it's worked. And then we can check that it's propagated our change through to our web application running on Hostinger, live on Hostinger. So obviously, I just want to cite that I'm using my VPS name here and the port number. You'd obviously want to map that to a proper URL, for example, www.magicstream.com or whatever it may be. I doubt magicstream.com is available, but something like that. And then we could access, obviously, this address through www.magicstream.com. And you'd also want to convert it to HTTPS. You can see not secure there. You want it to run on HTTPS and not HTTP. I've just used HTTP so that we can get the basics of our CI/CD pipeline working without too much convolution of our deployment code. Okay, and there you go. So it's running it through. It's doing the thing. It's doing quite a lot here, so it is taking a bit of time. So it's creating the images on DockerHub, and then it's going to pull those images down. Those images can change. Look at that. It's gone green. And it's got a tick, so that means it was successful. And we can refresh this now, and hopefully we'll see a header appear there. Look at that. Magic Stream heading. So now we can run our code locally. Okay, and what I'm actually going to do is create a new terminal here, and I'm going to use Docker Compose to run it in watch mode. Okay, so Docker Compose, and then -f Docker -compose YAML -f, and then Docker -compose.dev, because we're running it on our dev machine and our dev environment, and we want to run this in watch mode. So let's do that. Okay. Oh, okay. Sorry. Oops. Try that again. docker-compose.dev.yaml. Okay, in watch mode. Press the enter key. Great. Great, so it's running our containers now in watch mode. Now you can see we've got an awesome development environment. So I'm going to put that there, in the corner there. And let's go to our local version of Magic Stream here. So this is running it locally. Okay. So we're running this locally here. We're running Magic Stream locally, and we're running it in the right pane here in watch mode. And you can see now we could edit that heading. And when we save it, it in real time changes the heading. So let's do that again. Let's delete that. Great, changes it. So magic stream my awesome heading. And let's save that locally. Okay, so we're seeing our changes in real time on our development machines, and it's outputting status there for us, which is great. Okay, excellent. So let's go out of that now. Okay, and now if we go to Git bash, so let's say we're really happy with this incredible change here that we've made to our code. So we're just over the moon about this. And we really want this change made locally here. But at the moment, it's just magic stream heading. We want magic stream my awesome heading. So this is just magic stream heading, magic stream my awesome heading. And now we can push that change straight to GitHub, and it will publish it on Hostinger. Publish your change on Hostinger in real time. So we've got our CI/CD pipeline set up. We've got an awesome development environment that is where we can pipe our changes straight through to Hostinger in the live environment. And we've set up all the plumbing for that through Docker Compose and Hostinger. So git add dot, okay, git commit. And I'm just going to call this my awesome change. Awesome heading change, like that. Okay, we'll see that'll be the heading of our workflow when the GitHub action is doing its thing and running. Let's do that there. Great. And then git push. And that now should propagate through to our live environment. Okay, so let's go here. Okay, and you can see now if we refresh this, my awesome heading change, it's going through. So it's going through all the steps involved, creating the images, which now contains the new code, pushing those images to GitHub, to DockerHub, and then Hostinger can run Docker Compose and pull the images with the new changes in them down to Hostinger and run them as containers, and then down the old containers. So it should be all seamless to the user. The user just refreshes the browser. Like magic, that change is there. You know, you can push your changes through to your clients very fast. You can iterate very fast. And you can create staging environments and testing environments and, of course, production environments. And you can automate your deployment. And Hostinger makes this very easy to do. So I'm very impressed with this. Look at that, green tick. And hopefully now we should see this. This is our local version. Magic Stream My Awesome Heading has propagated through to Hostinger, the live version of Magic Stream. And look at that, Magic Stream My Awesome Heading. Okay, and let's I hope you've enjoyed this video as much as I enjoyed creating it. The perception amongst developers, including myself, regarding application deployment is often one of drudgery and pain. But it doesn't have to be like that. Hostinger's Docker Manager facility makes deployment automation incredibly simple and painless. And when you understand what is going on under the hood, you'll feel less worried about the perceived issues associated with deployment, and become more confident that your code that you had running perfectly on your development environment will work just as well in the production environment. I hope to see you soon. Thank you, and take care.